All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to Unacademy NEET English. How is everything going? Tell me, guys. How is everything going? Please let me know in the chats. Am I perfectly audible and visible to each and every single student? Let me know in the chats. And then we are going to start this particular session. And every single problem which has the probability to come in the NEET 2025 will be discussed from the capacitors in this particular session. Okay. And every single concept I'll be talking about from the basics, from the scratch. Okay. And when it comes to the electrostatics, you would have seen the level of content that I have provided in that particular one shot. Okay. So we say same level of content will be over here also. Everything will be from the basics, from the scratch. If you haven't studied this chapter before, okay, so you are going to understand each and every single thing. That is my guarantee. Okay, and this is a small chapter. It's not a big chapter. Okay, we'll finish it. And I would want you guys to hit the like button, smash the like button, everybody out there, because marking the attendance means liking the session. That is extremely mandatory. Okay, okay. And put up the fire in the chats. I would want you guys to send the fire emojis in the chats, okay? Light up the chats. As Wasim sir says, light up the chats with the fire emojis. So everyone means everyone. Everyone means everyone, okay? So let's take a look at your chats over here. Okay. Great. So tell me, guys. I hope you are liking this series, okay? You are watching the series continuously. Okay. Cool. So let the people join. Let everybody come and we'll start this particular session. We'll start from the scratch, from the basics, okay? Yes, I can see a lot of hearts, fire in the chats. That's great. Session duration will be, I'll try to finish this in 6 to 7 hours, okay? Okay, if possible, I'll finish in 6 only, okay, 6 hours only, because this is a small chapter. But I have added a lot of questions as compared to the last year, okay? As compared to the last year's one-shot capacitors, marathon of capacitors, I have added few more concepts. I have added a lot of questions out there, so it'll take a bit more time as compared to the last year. Okay. Great. I think we must start the session. I think we should start the session. Okay. Time to kill this particular chapter that we have over here. Okay, smash the like button, guys. If you have not liked the session, and I would want you guys to hit the like button as soon as possible. Okay, so let's get going. Let's get started with this chapter. That is capacitors one shot. That is capacitors one shot. Okay. Now, guys, let's take a look over here. The first concept we need to discuss over here is capacitor itself. What does the capacitor actually mean? Guys, see, let me give you a basic example, a simple example over here. I have got a fan, okay? Or you take any electrical device, be it a motor, be it a fan, be it a television, okay? Any electrical device. We say any electrical device, in starting, if you want to start this fan, if you want basically this fan should work, then we say in starting it requires high energy. Guys, see, we say any electrical device, any electrical device requires high energy while starting. So if you want to start this fan, if you want to start the television, it requires high energy. You'll say, sir, I'll have to use this fan, I'll have to start this fan. I'll take a wire over here and then I'll plug that in over here and it will start working. I say no. With the help of this simple wire directly, it is not possible to send that huge amount of energy. It is like if I say I have a block over here, okay? I want you guys to move this block. What will you do? You'll, sir, apply force. I say in starting, it requires a lot of force, a huge force. When it moves, when it slides, afterwards it requires little force. So in starting the block, in basically pushing the block while in starting, it requires large energy, huge force. Now guys, same is the case for this electrical device. While starting, it requires huge energy, which is not possible to which is not possible to send through a simple wire. So what we do instead is that we use the device that is what we call the capacitor. You might have seen in the fans this capacitor, like we have over here capacitor. So we say, guys, understand one thing very carefully. So we use a device called capacitor, We use a device called capacitor, which stores the energy. This device, capacitor, stores the energy. And while we want to start this fan, initially it sends that energy, okay? So then this electrical instrument starts and it works, and then you can send the energy with the normal line, with the normal supply. So we say we use a device called capacitor, which sends the large energy, to the electrical device while starting. So this is basically the use of capacitor. Why do we use capacitor? Because any electrical device requires huge energy while starting. So it is not possible to send that energy through a normal supply line. So instead, we use a device called capacitor, which stores the energy, and it sends all of that energy initially if you have to start any electrical instrument. Please let me know in the chats if this is crystal and clear to each and every single student. Let me know in the chats if this is crystal and clear to each and every single student. And hit the like button if you have not liked the session yet. Let me know in the chats if this is crystal and clear to each and every single student. And hit the like button, guys. Great. So can I say a simple thing over here? I can say a simple thing over here. What is that? I can say this capacitor. So capacitor is a device. So I can say capacitor is a device which stores electrical energy. Why do we use that energy? Where do we use that energy? In order to start any electrical instrument, any electrical device, we require that energy. So at that point of time, this capacitor sends that large amount of energy initially, and the electrical instrument starts. Okay. So from now onwards, I say capacitor is that device which stores electrical energy. Like you have a bucket. Bucket stores, let's suppose if you have a bucket over here, we can store water in the bucket. Bucket stores water. Bucket stores any other fluid. But when it comes to the capacitor, it stores the electrical energy. As simple as that. Now guys, let's talk about the capacitance. What does capacitance mean? See. If I say I have got a bucket over here, guys, understand very carefully. We say this bucket is used to store water. Okay. This bucket, it will have the capacity. How much amount of water we can store in this bucket? That is the capacity of this bucket. We say it will have capacity. And let's suppose if it has capacity 5 liters, means you can store 5 liters of water in this bucket. Similarly, when it comes to the capacitor, capacitor also has a capacitance. We say a capacitor has a capacitance, which is the capacity, of a capacitor, to store electrical energy. Okay, in the form of what? In the form of charge. It is the capacity of a capacitor to store the charge, to store the electrical energy, or we say, sir, charge / electrical energy. Okay. I hope this is crystal and clear till over here. Now, my dear friends, let's suppose if I say over here, let's suppose if I say I have got a capacitor. Let's suppose if I say I have got a capacitor. I'll take a sphere over here. Sphere means capacitor. Guys, capacitor is that device which stores charge. If you have got a sphere over here, I am saying that I am storing Q charge on the sphere. Okay, I'll say let's take a sphere over here. On which we store Q charge. Because we know we can store the charge Q, we can distribute the charge Q on the sphere. So on this sphere, I'm storing the Q charge, okay? Like on this sphere, I'm storing the Q charge, something like this. Now, my dear friends, you might have seen, I have told you in the previous class, if there is a sphere, guys, capacitance of a capacitor means how much capacity it has to store the charge. If I say this capacitor can store more charge, means it has got more capacitance. If I say this capacitor has got less capacitance, means it has got less capacity to store the charge. Capacity means ability of a capacitor to store the charge, to store the energy. More is the capacitance, more energy we can store. Now, if I say I'm taking a sphere over here or a spherical capacitor, I'm storing Q charge on it. Okay. We say due to this charge, potential will be developed on the sphere. We say potential will be developed. I have told you previously, if we have a sphere and charge is stored on it, we say potential is developed. It will create the potential. Now guys, I would want you guys to focus over here. Can I say V is the potential developed on the sphere? Now, if you store more charge, guys, if you store more charge, because I have told you previously, if you have got a sphere over here, on its surface, potential is equal to V is equal to KQ divided by R. If you remember, if you have a sphere, on the sphere charge Q is stored. I'm saying how much is the potential? Potential is KQ by R. More is the charge, we say more is the potential. As simple as that. Same is the case over here. If I am taking the sphere over here, on the sphere Q charge is present, V is the potential. Can I say this Q is directly proportional to V? Yes. More is the charge you are storing, more potential will be developed. Now I say replace the proportionality. Proportionality with a constant, with a constant. I would want you guys to replace this proportionality with a constant. So I can say Q is equal to C into V. I can say Q is equal to C into V. And my dear friends, where C is called capacitance, where C is called capacitance and is a constant, where C is called capacitance and is a constant. Okay, the ability of a capacitor to store the charge. More is the capacitance, more charge you can store. Like over here, if I say this has got the capacity of 10 liters, more water you can store in it. It has got more capacity. Okay. Now guys, understand one thing very carefully. Can I say from this particular equation, I can say C is equal to Q by V. So from equation first, I can simply say C is equal to Q divided by V. Now guys, one important point I would want you guys to focus over here. What is that? In this particular case, don't say capacitance is directly proportional to charge and capacitance is inversely proportional to the potential. No, we say C does not depend upon, this is an important point, charge. Okay, we say C does not depend upon potential. C does not depend upon charge, neither it depends upon charge nor it depends upon the potential. Why? Because C is a constant, guys. If I say this is a bucket over here, I am saying if, let's suppose you are saying, sir, its capacity depends upon water, like over here. Capacitance of a capacitor depends upon charge, means more charge you store, more capacitance will increase. No. Same is the case over here. It's like if you are storing the water in this bucket, okay? I am saying more water you store, more capacitance will increase, its capacity will increase. That is wrong. If it has 5 liters of capacity, means you can only store 5 liters. If you store more, that will be leaked out, that will come out, that will be leaked. Do you agree with me? Please tell me in the chats. Is this point clear? Capacity is a constant. Capacitance depends upon the dimensions. I'll write over here. We say capacitance C depends upon the dimensions of a capacitor. Like over here also, if you change the dimensions, if you make the bucket bigger, we can say more water you can store in this one. Okay. Yes, absolutely clear. Absolutely clear. Absolutely clear. Now guys, so we say C is equal to Q by V. C does not depend upon Q, C does not depend upon V, but the capacitance depends upon we say dimensions of the capacitor. As simple as that. Guys, hit the like button if you have not liked the session yet. Now, capacitance of a single capacitor or capacitance of a spherical capacitor. Guys, see. Let's suppose if I make a spherical capacitor over here. Okay. Sphere, it is a sphere, normal sphere, conductor. And I am saying, let's suppose the radius of this is R. Okay. Let's take a sphere of a radius R. Let's take a sphere of radius R. And let's store let's store charge Q on it. Let's store charge Q on it. As simple as that. Now, as I told you, if you store charge Q on it, we say potential V will be developed, due to which potential V is developed. Okay. Now, guys, recently I told you, guys, what is that? We say C is equal to Q divided by V. Okay. We just got this particular formula. C is equal to Q divided by V. Now, could you please tell me how much will be the potential developed on the surface as we developed on the surface? We developed on the surface of a sphere, We have recently studied, sir, if you have got a sphere and charge Q is on the sphere, how much will be the potential on the surface, sir? V is equal to KQ divided by R, where R is the radius. Now I would want you guys to put it over here. So we say, so capacitance I can write that is Q upon. Instead of V, I'll write, sir, KQ divided by V, sir, R. This and this will cancel. So R will go in the numerator. This will become R divided by K. Okay. Now, guys, can I say in this particular case, this will be R upon. What is the value of K? That is 1 by 4 pi epsilon naught. If you take this in the numerator, don't you think it will become 4 pi epsilon naught, because it is in divide over here, 1 upon something. It will go in the numerator, 4 pi epsilon naught R. So I can say capacitance of a spherical capacitor is 4 pi epsilon naught R. Now guys, in this particular case, you guys can clearly see that this capacitance depends upon the radius. That's what I was saying. We say it depends upon the radius. Guys, there is 1 or 2 topics left from the electrostatic, small topics, that I will cover at the end of this marathon. I have put up those slides also. Chill. My job, I'll do my job. Okay, just focus over here on the class. So I'll finish this capacitor session and afterwards I'll show you those 2 topics, just small 2 topics. Okay. So we say this capacitance depends upon the radius. Means if you change the radius, its dimensions will change. It will become bigger. Means you can store more charge. You can store more energy. That's what I was saying. So this is the capacitance of a spherical capacitor. And sir, is there any other type of capacitor also? Yes, there will be parallel plate capacitor. There is a spherical capacitor. So mostly we have to deal with the parallel plate capacitor in our syllabus. Now, an important question, extremely important. I would want you to focus exactly over here. See, I hope the screen is completely visible. Guys, see. Let's suppose I say I have got many small capacitors over here. And if I combine these capacitors, sir, how can you combine? By any means, I'll melt them, whatever it may be the process. So I'll join all of these capacitors, I'll form a big capacitor. All of these are capacitors, all these small capacitors are joined to form a big capacitor. Okay? Then, if I ask you, see guys, the charge on this small capacitor, and these are n identical capacitors, n identical capacitors. Charge on these capacitors is Q. Capacitance of these is C. Let's suppose potential developed is V. And radius of these capacitors is small r. Okay? So I have combined to form a big capacitor. Now guys, we say after combining, we say this big capacitor will have different capacitance because dimensions changed. It will have capacitance C dash. It will have capacitance V dash. It will have a radius R, capital R. And charge stored on this will be, let's suppose, capital Q. You guys are supposed to tell me the values of these. And directly, many times in JEE as well as NEET, the questions have been asked on this particular topic. I'll not derive it, but I'll tell you the direct formula, direct trick to remember, and you can solve every single question from this. That is my guarantee. Now see, when it comes to, how many capacitors, and these are N capacitors, keep this thing in your mind. See guys, we say when it comes to the small capacitors, even in some questions, they will write over here small drops, okay, small drops. N small drops are combined to form a big drop. N small spheres are combined to form a big sphere. Now see, we say small capacitors. Okay, let's suppose they have got the capacitance C. Okay, and let's suppose they have got the radius R. Okay, let's suppose they have got the charge Q. Let's suppose they have got the potential V, and they have got the capacitance C. Now, when it comes to the big capacitor, we say, guys, big capacitor has got capacitance C dash. Okay, first we'll talk about the radius. Okay, so it has got the radius R. Now guys, if somebody asks you what will be the value of this radius, directly remember, please don't ask me why, because there is a derivation for this. Volume of this will be equal to volume of this. From there you can calculate this radius. Okay, n times of this 4 by 3 pi r cube and all, and this will be having the 4 by 3 pi r cube. You can do that, but I want you guys to remember directly, radius will be equal to, that is n raised power 1 by 3. N means number of capacitors. N raised power 1 by 3 into small r. Small r is the radius of this capacitor. Then, sir, charge Q will be simply, if this is Q, capital Q, how many charges we have combined? N charges. So charges will be simply, that is N times of small q, because N capacitors are combined. 10 capacitors if you combine to 10Q. 100 capacitors you combine to 100Q. And when it comes to the capacitance, capacitance will be also N raised power 1 by 3 into C, where C is the capacitance of the small capacitor. And then potential. Sir, what is the potential of the big capacitor? Here only you have got 2 by 3 times of V. Potential of big capacitor will be equal to N raised power 2 by 3 into V. Now let's take a question. Let's take a look at the question which was asked in NEET 2021. Directly. How many of you can solve this question? In the chats, I would want you guys to answer me. Everybody, tell me in the chats, what is the answer of this particular question? Everyone means everyone. I would want you guys to tell me the answer of this particular question ASAP, as soon as possible. Smash the like button, guys. Smash the like button. Yes. Great. See, guys, in this particular case, we say 27 drops of the same size are charged at 220 volts. We have got the drops over here, or the small capacitors. How many? N is equal to 27. And they are combined to form a big drop. Okay. Calculate the potential of the big drop. We are supposed to find the value of V dash over here. And potential of small drop is given as, V is given as, that is 220 volts. Directly, can I say, if N capacitors are joined to form a big capacitor, this will be the capacitance of the big capacitor. Yes, sorry, potential. So as I can say, V dash is equal to N raised power 2 by 3 into V. So V dash will be simply N. What is the value of N? That is 27 capacitors, and this is 2 by 3 into V. V in this particular case is 220. That is 220. That is potential of the small capacitor. Now, can I say this is 27? I can write it something like this. This is 27. And then it is 1 by 3 into 2. I can write it something like this. Once again, 2 into 1 will be 2 divided by 3. Now, what is this? 27 raised power 1 by 3. That is cube root of 27. Like we said, 25 raised power 1 by 2. This is square root of 25 and that is 5. Cube root of 27 is 3. Sir, why? Because 3 into 3 into 3 is 27. 4 into 4 into 4 is 64. So we say it is cube root of 20. This is, we say, sir, 3. And then you have got square over here. Square over here. Same I can write this V dash will be. That is, instead of 27, I can write 3. And I can say over here, this is 3 square. And this will be 220. 3 square is 9. 9 into 220 will come out to be, V dash will come out to be 1980 volts. So potential of the big drop, big capacitor is 1980. Even if somebody asks you, what is the capacitance of the big capacitor? Also, capacitance of the big capacitor. Also, how can you tell me the capacitance, sir? We know capacitance C dash is equal to, that is N raised power 1 by 3 into C. Let's suppose the capacitance of this is given as C. So I can say C dash will be, N is over here, that is 27 raised power 1 by 3 into C. So 27 cube root will be how much? That is 3 times of C will be capacitance. Even you can find the radius. Radius will be R times of R. Sorry, 3 times of R. Okay. And even if you can find the charge, charge will be how much? 27 times of Q if the charge of this is Q. Guys, tell me in the chats, is this crystalline clear? I would want you guys to tell me, everybody over there. Let me know with the fire emojis if this is crystalline clear. If this is crystalline clear. Then we have got one more question. Is this crystalline clear? Please tell me in the chats. Great. Now guys, here in this particular case, it is saying that we have got 64 small drops of water. 64 small drops of water whose charge and radius are same, are joined to make a big capacitor. So here we have, in this question, we have N is equal to 64. And they are joined to form a big capacitor. Okay. We are supposed to find the capacitance of the big capacitor. As I recently told you that capacitance of big capacitor C dash will be N raised power 1 by 3 into C. So C dash will be, N is how much in this case? That is 64. So that is 64 raised power 1 by 3 into C. So C dash in this case will be 64 cube root of 64. That is 4C. So this is 4C. Answer in this case is, we say 4C. Okay. This is the answer. That is 4C. Let's move on to the next one. Okay, guys. Now. Let's take a look over here. Perfect. Let's take a look over here. See, guys. Now, let's talk about, we say, parallel plate capacitor. Till now, we were discussing the spherical capacitor. Till now, we were discussing the single capacitor or single conductor. Now, let's talk about the parallel plate capacitor. Guys, see, sir, what is the problem with the spherical capacitor? Why do we have to make the parallel plate capacitor? See, if I say I have got a capacitor over here, single capacitor, or we say spherical capacitor, sphere, conductor. I am storing the charge on this one. Where do you have to store the charge? We say, sir, we store the charge something like this over here. On the surface, I'm storing the charge. Okay. Now, guys, in this particular case, I am saying the simple thing over here. I'm saying a simple thing. There are high chances that energy will be leaked over here. We say high chances of energy leakage. Of energy leakage. Why? Because this charge over here is open to air. It is not bounded by something. So we say this can be leaked from the capacitor. Okay? This can be leaked from the capacitor. So you want to make a better capacitor in which energy is safe. In which energy is safe. Okay? And that is what we call the parallel plate capacitor. That is what we call the parallel plate capacitor. So I can say if I make the parallel plate capacitor over here, guys, see. I'll make it something like this. I have got one plate, okay, and then I'll make one more plate over here. This is one more plate, okay, and this plate is having, let's suppose, area A. It is having the area A, and separation between the plates is, let's suppose, D. This is what we call the parallel plate capacitor. If you have the two plates, this is one plate, this is another plate, and these two plates are placed parallel to each other, this is what we call the parallel plate capacitor. I say, I'll write over here, when two plates are placed, parallel to each other, at some separation, it forms parallel plate capacitor. It forms parallel plate capacitor. And in this case, energy is stored between the plates. I'll say over here, energy is stored between the plates. Okay, so energy is bounded over here. Energy is safe over here. Now guys, in this particular case, whenever we talk about a capacitor, we say it has capacitance, because we know capacitor is a device which stores energy, so it has capacitance. So we say as it has capacitance. Guys, see, when it comes to the capacitance of a spherical capacitor, that was 4 pi epsilon naught R. But when it comes to the capacitance of a parallel plate capacitor, we say this capacitance is simply, I'll write over here, C is equal to, that is epsilon naught A divided by D. Epsilon naught A divided by D. This is the capacitance of a parallel plate capacitor, where A is area, epsilon naught is permittivity of free space, and D is the gap or the separation between the plates. D is the gap or separation between the plates. Okay, I hope this is crystalline clear till over here. Guys, tell me in the chats. So parallel plate capacitor simply means, if you have got, sir, will you complete 2 chapters per week? We cannot complete 2 chapters per week because it takes a lot of time to make the slides, to make the content, okay? And we take the session for complete 12 hours. So it is very difficult for us to take 2 sessions per week. But still, in some chapters, if we try to manage, we will do it for sure. Okay? Now. So we say in this particular case, this is the parallel plate capacitor. Now guys. There was a question, very basic question, very simple question asked in NEET 2022 on parallel plate capacitor. If the area of the parallel plate capacitor, if the area of the plates is halved and distance between the plates is doubled, find new capacitance. See guys, the question says that you have got a parallel plate capacitor, okay? Its area is A and this separation over here is D. What will be its capacitance? C is equal to epsilon naught A divided by D. Okay. Then it says that if the area is halved, we say finally, its area is halved, means the area of this plates is, we say, sir, halved. Area becomes A by 2. And the separation between the plates, this is doubled, so it becomes 2D. Here it is D, here it becomes 2D. We are supposed to find new capacitance. Can I say capacitance of this is, let's suppose, C dash. C dash will be simply, that is epsilon naught A by D. Instead of A, what is the area over here? That is A by 2. So I can write A divided by 2. And D, instead of D, I'll write over here, that is 2D. 2 into 2 is 4. So C dash will be epsilon naught A divided by, we say, 4D. Now, epsilon naught A by D is what we call the capacitance C. So I can say C dash will be C divided by 4. So means capacitance has been decreased by 4 times. So it becomes C by 4. Is this crystalline clear? This was the question in NEET 2022. Easy question, very simple question. Let's take a look at this question, guys. Let's take a look at this question. Here in this particular case, it says that the capacity of a parallel plate condenser is 15 microfarad. We have got a parallel plate capacitor over here. Okay. Its capacitance is given as 15 microfarad. Okay. And one more thing, we measure the capacitance in farad. Like we measure the charge in coulomb. Similarly, we measure the capacitance in farad. Here it is given microfarad. Okay. And guys, when the distance between the plates is 6 centimeter, means when the distance between the plates is 6 centimeter. So when capacitance is 15 microfarad, it says that the distance is 6 centimeter. Okay, yes. And finally, it says that, finally, this is initially, if the distance between the plates is reduced to 2 centimeters, it says that if we reduce this distance between the plates, okay, if we reduce the distance between the plates as this D, if it reduced to, we say, sir, 2 centimeter, we are supposed to find the new capacitance in this particular. Simple question. Guys, what is the capacitance over here? We say, sir, capacitance is epsilon naught A divided by D. And what is capacitance over here? That is 15 is equal to epsilon naught A divided by D is 6 centimeters. So I'll place over here 6. This is the equation number 1. Simple thing. And here they have not mentioned anything about the area, so we'll take the area as same. Then what is the capacitance over here? Sir, C dash is equal to epsilon naught A divided by D is how much over here? That is 2. Let's call this as equation 2nd. Now I would want you guys to divide first and second. So I say divide. We say first and equation 2nd. If we divide first and second, so can I say that will be 15 divided by C dash. This is equal to this side, okay, right hand side, that is epsilon naught A divided by 6 upon this epsilon naught A divided by 2. Epsilon naught A divided by 2. This and this will cancel. 2 ones are, so I can write it something like this. This is 1 upon 6 and you can take this over there. So it becomes 2 divided by 1. Okay. Now 2 ones are 2, 3s are 6. Now I'll write it this over here. So this is 15 divided by C dash is equal to, so it becomes over here, that is 1 divided by 3. Now do the cross multiplication. C dash is equal to 45 microfarad. So 45 is the answer. That is option C. Okay. Next we have got a question. This is a good question actually. The radius of a parallel plate capacitor is R. And air is the dielectric medium. If the capacity of this capacitor is equal to that of the sphere of radius R. See, what does the question say? The radius of a circular parallel plate capacitor. Circular parallel plate capacitor means what? We have got a circular plate over here. We have got a circular. It's kind of 2 discs. You have got one disc, you have got another disc. That one was the rectangular parallel plate capacitor. This is circular parallel plate capacitor. The radius of the circular parallel plate capacitor is given as R. So this radius is given as R, small r. It is given as small. Okay. And here is the dielectric medium. Ignore this point, dielectric medium, because we have to study this after some time. If the capacity of this capacitor is equal to, it says that the capacity of this capacitor is equal to the capacitance of a sphere, is equal to the capacitance of a sphere of radius r. Means, guys, let's suppose if this is the distance over here, that is d. It says that the capacitance of this is equal to the capacitance of this. How much is the capacitance over here? Capacitance of a parallel plate capacitor is epsilon naught A by D. And capacitance of this is 4 pi epsilon naught R. For a sphere, we know. How can we write this? We can write this as this is epsilon naught. Area. Guys, what is the area of this kind of disk over here? That is pi r square. So it will be pi r square. If r is the radius, divided by, we say, sir, d. Now, can I say both of these are equal? So we say as capacitance of this is equal to the capacitance of this. So I can say epsilon naught pi r square divided by d will be equal to 4 pi epsilon naught r. Now what we are supposed to find out? Then the distance between the plates is, we are supposed to find this d. So we say pi and pi will cancel out, okay? Epsilon naught will cancel out. So d, take it over here. So d will come out to be, this is r square divided by 4. R square divided by 4r. Option A. Guys, give me the signal in the chats. Is this crystalline clear? I would want you guys to tell me in the chats if this is crystalline clear to each and every single student. Let me know in the chats if this is crystalline clear. Everyone means everyone. Great. And guys, smash the like button. I would want you guys to smash the like button as soon as possible. If you have not liked the session yet. If you have already liked, please don't like it once again. Okay. Now, energy stored in a capacitor. Guys, see. As we have been telling, or we have been discussing the fact that is capacitor is a device which stores the energy. Now, if somebody comes and asks you how much amount of energy is stored in the capacitor, okay? We know as capacitor stores the energy. So let's find that out. Let's find out that energy stored in a capacitor. Guys, see. I would want you guys to focus exactly over here. Guys, let's suppose if I say I have got a parallel plate capacitor over here. Let's suppose if I have got a parallel plate capacitor over here. Okay. Yes. This is one plate and this is another plate. These are the two parallel plates. Okay. Now, what I want you guys to do in this particular case is, I want you guys to connect a battery to it. This is the symbol of a battery. Don't get confused, okay? Battery is which we, like, guys, you have the battery. Like the battery which is connected to the inverter, okay? Which stores the energy, okay? Or which provides the energy. That is the correct thing to say. Which gives the energy. So I'm connected. This is the symbol of that battery. Okay. What is the work of the battery? To supply the energy. Okay. Now see, I will tell you how capacitor stores the energy and how capacitor is charged. Guys, see, if you have a capacitor over here, if you want to charge this capacitor, if you have a mobile phone, if you want to charge the mobile phone, what will you do? You'll take a battery, okay? And you'll connect the switch over there and supply over here, and then it will be charged. Now, my dear friends, I have capacitor over here. It's uncharged. No energy is stored. Then we connect a battery over here. We say, I'll write over here, as we connect the battery to a capacitor, as we connect a battery to a capacitor, we say, this battery will basically, this is what we call the negative terminal of the battery. This is what we call the positive terminal of the battery. Whatever I say, just remember it. We say this battery will take the charge from one plate and it will place onto the another plate. Guys, directly remember, this battery, this is, guys, if I say this is a sphere over here, if I say the amount of positive charge on it is equal to the amount of negative charge, net charge is 0. I am saying, take the positive charge from this, take the positive charge from this. What remains over here? Negative. If you take 2 positive charges, we say 2 negative charges, we say have increased over here. So this battery will take the charge from one plate. Okay, I say small charge, that is DQ, positive charge. Because this is the positive terminal. It will occupy positive over here. It will place the little positive charge on this plate. If little positive charge comes onto this plate, we say negative charge occupies over here. Because we know, if positive charge leaves some position, negative occupies. Because we say negative will become more over here. Now, if I say the battery will do more work, then it will take more charge over here and place over here. So this is more positive, more negative, more positive, more negative. If I say plus Q charge is stored on this one and minus Q charge is stored on this one. Can I say, as we connect the battery to the capacitor, which will take the charge from one plate to another. Okay, you can also understand it something like this. This battery takes the electrons from this plate and places it over here. So negative charge comes onto this one because electron has negative charge. So positive charge will be occupied over here. Whatever the way you want to understand this, you can. Okay. So I can say, who is taking the charge from one plate to another? It is battery. Is the battery doing the work done? Yes. So I can say in this particular case, okay. So battery is doing the work done. Battery is doing the work done in moving the charge from one plate to another, in moving the charge. Okay. Now, I have told you previously, the work done by external agent is not, it will not go into the waste. It will be stored in the form of energy. And that work done will be stored in the form of energy of a capacitor. That work done will be stored in the form of energy of a capacitor. So the job of the battery is not to supply the charge. The job of the battery is to do the work done, to give the energy so that the charge moves from one plate to the another plate. Okay. And if I say over here, Q charge is, if I say plus Q minus Q means Q charge is occupied. If I say plus 2Q minus 2Q means 2Q charge is occupied. So we say in this particular case, let the charge Q is stored on the capacitor, Okay. So we say this work done will be stored in the form of energy, and that energy will be, that energy will be. Guys, see. I can say U is equal to, okay? I can say U is equal to, how much is the charge stored on the capacitor? That is, sir, Q, and I'll take it square, Q square. And how much is the capacitance of this capacitor? That is C, divided by, I say over here, that is Q square by 2C is the energy stored, in the capacitor, where Q is the charge stored, C is the capacitor. This is the energy. And that work done by the will be stored in the form of energy of a capacitor. Guys, please tell me in the chats if this is crystal and clear to each and every single student. Let me know in the chats if this is crystal clear to each and every single student out there. I would want you guys to give me the signal in the chats. Guys, with the fire emojis, everyone means everyone. Okay? Smash the like button if you are not liked, ladies and gentlemen. Okay? Now, guys, I would want you to tell me this one. See. We say, as energy stored, U is the energy stored in the capacitor. That is Q square divided by 2C. And I have told you the logic how energy is stored in the capacitor. It is because of the battery. Battery is doing the external work done, moving the charge from one plate to another plate. And then that work done is stored in the form of energy. So U is equal to Q square by 2C. Now, guys, tell me one thing. Can I say over here, as we know, what do we know? We say Q is equal to C into V, because we say C is equal to Q by V. So I can say Q is equal to C into V. Now put it over here. We say energy will come out to be, that is C square V square divided by over here, that is 2C. C and this square will cancel out. U will come out to be, that is 1 by 2 CV square. So this is also the energy of a capacitor in terms of potential and potential difference, and we say capacitance. This is also the energy. This is also the energy of a capacitor in terms of, this is also the energy of a capacitor in terms of, we say, capacitance, and potential. Yeah, voltage. Okay, yes. Now guys, can I say one more thing over here? What is that? We say as. We can also say once again, we can say over here, what is that? We can say, sir, this C is equal to Q by V. C is equal to Q by V. Now put it over here. So I can write U will come out to be 1 by 2. Instead of this C, I can write that is Q by V into this V square over here. This and this will cancel. So U will come out to be 1 by 2 Q into V. Sir, is this also the energy of a capacitor? Yes. So we say this is the energy of a capacitor in terms of charge and voltage. This is the energy of a capacitor in terms of charge and voltage. This is the energy of a capacitor in terms of charge and voltage. Next, guys, is this clear? So we have got the three formulas over here. First is Q square by 2C. Then we say 1 by 2 CV square. Then we say 1 by 2 Q into V. All of the three are the first. Sir, in which month physics will be completed, sir? In which month physics will... Are you talking about this game of NEET? Please count the next... How many days left? 68 days. Please count and do let me know also in the chats. When will we complete the physics? Now, guys, so we say we have got the three formulas. Q square by 2C, 1 by 2 CV square, and then we have got 1 by 2 Q into V. Is this clear? Is this clear? And how energy is stored in a capacitor? Because of the battery. Battery does the work done in taking the charge from one plate to another plate, and we say energy is stored. Energy is stored. Let's take a look at this question. Let's take a look at this particular question. Let me know the answer of this particular question in the chats. Everyone means everyone. Everyone means everyone. This is a simple question. I would want you guys to tell me in the chats. Come on. Come on. Tell me, guys. See, in this case, a capacitor of capacitance 700 picofarad. If you want to convert this into farad, you just write simply 700 into 10 raised power minus 12 farad, because it is given in picofarad. So when you convert, you have to multiply with 10 raised power minus 12. Is charged by 100 volt battery. This is given as capacitance, and voltage is given as, that is 100 volts potential difference. You are supposed to find electrostatic energy stored by capacitor. Guys, see. Guys, see. In this particular case, C and V is given. You are supposed to find energy. Which of the three formulas you are going to use? I think this one, 1 by 2 CV square. So I'll write over here as U is equal to 1 by 2 CV square. So U is equal to 1 by 2. What is the value of C? That is 700 into 10 raised power minus 12 into V square. V is given as, we say, 100 square, 100 square, 100 volts. Okay. So this will come out to be, that is 350. 700 divided by 2 is 350. Okay. Into 100 square is 10 raised power 4. And 10 raised power 4, 10 raised power minus 12. So it will become 10 raised power minus 8. And if you can also write it something like this, that is 3.5 into 10 raised power minus 6 joules. This would be the energy in this particular case. This would be the energy. Next, you have got this. Okay. Two condensers, one of capacity C and other of capacity C by 2. Guys, please remember for 5 minutes, not for 5 minutes, for 30 minutes, because after 30 minutes, I'll have to teach that. Guys, see, let's suppose you have got a capacitor. What is the symbol of a resistor? Sir, the symbol of a resistor is this one. We have studied previously in class 9, 10th. What is the symbol of a capacitor? The symbol of a capacitor is this. If I say this capacitor and this capacitor, are they connected in series or parallel? Are these two capacitors... Wait. I'll zoom it, please. Are these two capacitors connected in series or parallel? We say, sir, parallel. Let's suppose this is C and C. Sure, if you have got the two capacitors connected in parallel, we find their net capacitance equivalent. Please remember it. I'll teach you separately. We find their equivalent capacitance equivalent as C1 plus C2. That is C1 plus, we say, sir, C2. That is C plus C is, we say, sir, 2C. Okay. In parallel combination. Now see. In this particular case, I would want you guys to focus over here. You have got one capacitor. It has got capacitance C. You have got another capacitor. It has got capacitance C by 2. They are connected in parallel. This C and C by 2 are connected in parallel with V. You have to tell me the work done in charging them. See. It is like this. I'll make the new figure over here. This is, we have got a battery over here. And then you connect a capacitor you connect one more capacitor over here. This is V, this is C, and this is C. Okay, this is C by 2. Another one is C. Now. Guys. In this particular case, I am asking you the simple thing. What is that? That is, sir, when you connect a battery to the capacitor, battery does the work done. Okay, we say here, battery will do the work done. Okay, and because of that work done, energy will be stored in this capacitors. And that work done itself will be stored in the form of energy. So I can say, whatever is the work done in charging the capacitor, okay? Work done in charging the capacitor. We say work done in charging the capacitor. That will be stored in the form of energy. Now, what will be that energy? How much is that energy? 1 by 2 C V square. Now, here you have got two capacitors in parallel. How much is the equivalent capacitance? C equivalent will be simply C1 plus C2 because these are connected in parallel. So, C by 2 plus C, that is C by 2 plus C. That will be 2C plus C, that is 3C by 2. So, instead of C over here, you have to write C equivalent. Because if it was only one capacitor, you would have written over here, that is CV square. If anybody is getting any sort of confusion in understanding this, please skip this question for some time. I'll teach you once again this one. So we say energy will be over here 1 by 2 C equivalent. That is 3C divided by 2 into V square. So that will become 3C V square by 4. 3 by 4 CV square. So this is the answer. See, the question was saying that if you have got the two capacitors in parallel, you connect a battery to it, okay? Then this battery will do work done over here. We know when you connect a battery to a capacitor, it will do work done. You have to find that work done. And we know the concept. The work done by the battery will be stored in the form of energy. That work done itself is stored in the form of energy. So if you have to find the work done, you find the energy, one and the same thing. And energy will be 1 by 2 CV square. Instead of C, you have to take C equivalent over here. That's what I'm trying to say. Let's move on to the next question. This question. This was asked in. I hope this is visible, okay? I hope this is visible. Okay. A capacitor is charged. Okay, let me give you this as a homework. Afterwards, once you are done with the session, do comment its answer in the comment box. Comment box. Okay. All right. Or right over there, done, sir. Okay. So this is your homework. This was asked in NEET 2017. Give it a shot later on. Now, guys, let's talk about. Is this clear till over here, guys? Let me know in the chats. Let me know in the chats. Is this clear till over here? Everyone means everyone. Okay, great. Now, guys, see. Force between the plates of a capacitor. Guys, see. Let's suppose if we have got the parallel plate capacitor over here. Let's suppose I am taking a parallel plate capacitor. Let's suppose I'm taking a parallel plate capacitor over here. Okay. And in this particular case, I am connecting a battery to it. Let me connect a battery. I am connecting a battery to it. Okay. Now, guys, what will this battery actually do? We say because of this battery, we have recently studied positive charge it will charge the capacitor. Positive charge comes onto one plate and negative charge come onto the another plate. Okay. Guys, tell me one thing, please. Everyone means everyone. If positive charge is on this plate, let's suppose this is Q plus Q. Negative charge is on this plate, that is minus Q. Don't you think that, please, don't you think that this positive charge will attract the negative charge? Because positive and negative will attract each other. Okay. So we say, as due to the opposite charges on the plates, due to the opposite charges on the plates, they will attract each other. They will attract each other. So they attract each other because positive attracts negative. So if they attract each other, means they are applying force on each other. This plate will attract this positively plate towards this with a force F. This positive will also attract this towards itself with a force F. So I say in this particular case, as due to the opposite charges on the plates, they will attract each other. So they apply force on each other. And guys, that's what we call the force between the plates of a capacitor. It's actually because of the charge they have. So that force will be F is equal to, we say Q square upon, Q is the charge on the plates, Q square upon 2A. A is the area of the plates. 2A epsilon naught. This is the force between the plates of a capacitor. Q square upon 2A epsilon naught. Now, guys, as I have told you in the last class, whenever you take a sheet, in case of a sheet, we define sigma. If I say this is a sheet over here. On this sheet, charge Q is present and its area is A. And here, on the entire area, Q charge is present. If I ask you how much is the charge present on this unit area, so you say, sir, that will be sigma. Sigma is total charge divided by total area. That is Q divided by A. That is surface charge density. Now, if this is a plate, here also, we take sigma. In case of sheet area, we take sigma. Please don't ask me what is that. I have already discussed. Now, we say as. Sigma is equal to Q divided by A. Q is the charge present on the sheet, on the area. A is the area of the plate. Now, if you put it over here, and I can write over here, sir, Q will come out to be, that is sigma into A. Now, instead of this Q, can you put sigma into A? Yes. So I can say in this particular case, this force will come out to be. Here I can write this will be sigma square because it is Q square. So sigma square into, we say, A square upon. Then we say 2A epsilon naught. So I'll write 2A epsilon naught. Now this square and this will cancel over here. So force will come out to be, that is sigma square divided by 2A epsilon. So I can say this is the force. This is the force in terms of sigma. And this is the force between the two plates. This is the force between the two plates. Okay. Yes. So here A and A will cancel. Just a second, I'll write it over. So I can write over here, this is Q is equal to sigma into A. So I can say force will come out to be, instead of Q, it will be sigma square into A square upon. And over here in the denominator, it is 2A epsilon naught. This A and square will cancel. So it will come out to be, that is sigma square A divided by 2 epsilon. Okay. So I can write finally, so force is also equal to, that is sigma square A divided by 2 epsilon. So we say this is the force in terms of sigma. This is the force in terms of sigma. This is the force in terms of sigma. Is this clear? Please tell me in the chats. Is this clear? I studied from you and I scored 171 in physics, 696 in NEET 2024. That's great. That's great, Ujjwal. Okay. Next year, I would want you guys to write the message something like this in the chats. Okay. And I would want you guys to score 180 out of 180 in physics. Challenge accepted. Yes. Now, guys. So this is basically the force between the plates of the capacitor. Force between the plates of a capacitor in terms of sigma, and this is in terms of charge. This is in terms of charge. Now, guys, I would want you guys to listen to me. See. We say as. If we talk about the pressure, we say pressure is equal to force per unit area, force upon area. Guys. Always remember, let's suppose if you have got over here an area. Let's suppose if you got an over here an area. Okay. And on this area, if let's suppose force is acting, okay? On this area, if let's suppose force is acting. Whenever force acts on some area, we say pressure is created, okay? We say pressure is created. So if I'm pushing this area over here, means pressure is created. Force divided by area means pressure, as simple as that. Now, can I say in this particular case, force is acting on this area of the plates. So there will be pressure acting on the plates, okay? So there will be pressure acting on the plates, yes. And when we talk about the pressure, what is the value of force we recently got? That is sigma square A divided by 2 epsilon naught. We say that is sigma square A divided by 2 epsilon naught. And divided by area, it is A. A and A will cancel. So pressure will come out to be, that is sigma square upon 2 epsilon naught. And this is the pressure. This is the pressure on the plates of the capacitor. This is the pressure on the plates of the capacitor. Okay. So this is the pressure on the plates of the capacitor. That is sigma square upon 2 epsilon naught. Now guys, I would want you guys to remember one more thing over here. What is that? We say the dimensions of pressure is the same as the dimensions of energy density. Guys, see. Directly remember over here. Directly remember over here. We say whatever is the dimensions of pressure, same comes out to be the dimensions of what? Energy density. We say as dimensions of pressure is same as the dimensions of energy density. So my dear friends, what I want, don't get confused over here. Don't get confused over here. Whatever is the formula of pressure, same is the formula of energy density. Just remember it directly. So I can say energy density. I'll tell you what is energy density. Please wait for some time. Energy density is simply whatever is the formula of pressure, that is, we say, that is sigma square divided by 2 epsilon naught. This is what we call the energy density, or we say pressure. Now guys, see. What is energy density and what is energy? I'll tell you the difference. Let's suppose I say I have got a sphere over here. This is a sphere. I say I have got a sphere over here. Okay. Now, I am saying that the total energy stored in the sphere is E. E is the total energy in the entire sphere over here. If I ask you the simple question, what is the volume of this sphere? You say, sir, volume of this sphere is V. Total volume, total energy. What if I ask you to tell me how much is the energy in the unit volume? How much is the energy in the unit volume? So we say this is energy in unit volume. That is also what we call the energy per unit volume. And how do we find that? That is what we call the total energy divided by total volume. Like previously I told you, if I say I have got a rod over here. On this rod, Q charge is present. L is the length of the rod. If I ask you the simple question, how much is the charge present on the unit length? You say, sir, that is Q by L, charge per unit length. Okay. Total charge by total length. Same is the case over here. How much is the total energy stored in this volume, in this sphere? You say, sir, E. How much is the total volume, E? How much is the energy present in the unit volume? That is energy in the unit volume. That is energy per unit volume. And this is what we call energy density. Energy density. Guys, whatever I mention over here on the board, make sure you write all of these things. So can I say this energy density means that is energy per unit volume will be equal to, that is, sigma square divided by 2 epsilon naught. Yes, I can write it something like this. Energy per unit volume. Energy in the unit. And what is this E? E is the total energy. What is this V? V is the volume. So I can say from here, this energy you can write. If you multiply this V over here, don't you think that you can write sigma square divided by 2 epsilon naught multiplied by volume? And when it comes to the parallel plate capacitor, how much is the volume? Volume of a parallel plate capacitor will be simply area of the plates multiplied by separation between the plates. Okay, that is we say, sir, this is D. Area into distance. We say, as for parallel plate capacitor. As for parallel plate capacitor, I can say this energy will, as I can say, we say volume is equal to area into distance multiplied by area into separation. So energy, total energy will come out to be sigma square divided by 2 epsilon naught A into D. Guys. See. Previously, yes, U and E is same. U and E is same. U and E is same. Where I'll write over here. I'll write over here. Where E is the total energy stored in a capacitor. Guys, where E is the total energy stored in the capacitor. I would want you guys to focus over here, please. This is the formula of energy of a capacitor in terms of sigma. And come over here. This is the formula of energy of a capacitor in terms of charge and capacitance. This is in terms of charge and voltage. Oh, sorry, capacitance and voltage. This is in terms of charge and voltage over here. And this is the formula of energy of a capacitor in terms of sigma. And here you have area and separation between the plate. Now, guys, see. One more thing I'll tell you over here. One more small thing I'll tell you over here. As we say energy came out to be E is equal to, either you call it E, either you call it U, one and the same thing. That is, we say sigma square divided by 2 epsilon naught, and then we say A into D. Guys, tell me one thing. See, I'll give you the proof. Don't get confused. We say as when it comes to sigma is, we say, sir, Q divided by A, charge per unit area. So I can say this U will come out to be, instead of sigma, I'll write Q square divided by 2A square, because sigma square, it will be Q square by A square. 2A square into epsilon naught, and then we say A into D. Now this A and square will get cancelled out over here. Now, can I just write in this particular case, U is equal to, guys, see. This is Q square upon 2 epsilon naught, and then we say multiplied by D over here. We can write it something like this. Now. Can I say in this particular case, if I want you guys to focus over here, and we have over here also, that is A. Now, can I say in this particular case, take this D and place in the denominator. So I'll say U is equal to Q square divided by 2A, I'll write over here something like this, 2 epsilon naught A, and take this in the denominator D, because if you take it once again, it will go in the numerator. Now, what is this epsilon naught A by D? This is the capacitance of a parallel plate capacitor. So I can say U is equal to, that is Q square upon 2, and what is this? C. Guys, do you know this expression? Have you ever met this particular expression ever? Do you know this expression? Have you ever met this particular expression? Yes, this is the energy stored in a capacitor in terms of Q and C, already discussed. And see, how did we get this? Because of this. So means this equation is correct. We got this equation because of this. So means this equation is absolutely correct. This equation is absolutely correct. This equation is absolutely correct. Okay. I hope till over here everything is crystal clear and sorted. I don't think there is any sort of confusion. Is that clear? Is that clear? Guys, smash the like button. I would want you guys to smash the like button. Everyone means everyone out there. Is my voice low, guys? Or is it clear? Is my voice low, or is it perfectly fine? Let me check. And I would want you guys to score 180 out of 180. It's perfectly fine, guys. What are you saying? No. So we are done with this. Let's now solve this question. And this was the question which was asked in JEE Mains 2021. JEE Mains 2021. This is actually a good question. Okay, let me show you over here. Let me make the figure over here once again. See, guys. It says that we have got a parallel plate capacitor. This is a positively charged plate over here. Okay. And we have got a negatively charged plate over here. This is negatively charged plate. It's placed something like this. It's placed something like this. Yes. Now, guys, in this particular case, it says that an electron enters with the kinetic energy K1. It says that an electron enters over here. This is an electron. It enters in this region. It enters in this region. Okay. This electron, it's difficult to make. See, guys, I hope this is visible. I hope this is visible. See, it says that an electron enters with a velocity u, in this parallel plate, okay. Then it follows this particular path and goes out. Here it has kinetic energy K1. Here it has kinetic energy K2. Okay. In this case, it has got kinetic energy K1. I can't zoom it. Here it has got kinetic energy K1. Here it has got kinetic energy K2. And when it is entering over here, it is making an angle of alpha. And when it is leaving over here, it is making an angle of beta with the horizontal. Okay. Now, guys, if this is the positive charge, this is negative charge. I have told you in the last class that electric field is always set up from positive to negative. Electric field is always set up from positive to negative. So when this electron, guys, see, when this electron enters this, okay, with a velocity u at an angle of what? At an angle of alpha. We say, sir, electric field is from positive charge to negative charge. Okay. And we say force will act on it in the if this is the direction of electric field, force acts in the opposite direction. Don't ask me why. Because in the last class, I told you, if this is the direction of electric field, if you place the negative charge in this electric field, force acts on this in the opposite direction, in the backward direction. So force acts in the backward direction. Okay, that is equal to Q times of E. Same. If this is the direction of electric field, force acts in the opposite direction. Now we say this electron will come, and it will go out of this electric field with a velocity u. Sorry, with a velocity v. And here it will make an angle beta. It says that at this particular position, it has got the kinetic energy K1. Here it has got kinetic energy K2. We are supposed to find the ratio of kinetic energy. I say we have to find, we say K1 divided by K2. A simple thing is, if let's suppose it has mass m, here, its kinetic energy will be 1 by 2 mu square. Because kinetic energy of a particle which has mass m, it is 1 by 2 mv square. Here it has got u velocity, so 1 by 2 mu square. Divided by, here it has got v velocity. So I can say it will be 1 by 2 mv square. As simple as that. Now, 1 by 2m will cancel. So kinetic energy K1 divided by K2 will come out to be, that is u square divided by v square. Let's check for the options. See, if you take a look at the options, none of the options is matching over here. Because it is sine square beta by cos square alpha, cos square beta by cos square alpha. Now see guys, one more thing in this particular case. What is that? Sir, that is shear force is acting in the vertical direction. Your force is acting in the vertical direction. Okay? Your force is acting in the vertical direction. So we say force in x direction is equal to 0. So force in x direction is 0. No force is acting in the horizontal direction. So guys, remember, please, kinematics concept is involved over here. If there is no force in x direction, we say acceleration in x direction is equal to 0. Okay? Now use the formula. We say V is equal to U plus A into T. We use this formula in x direction, Guys, please see. If I am saying acceleration in x direction is 0, okay, acceleration in x direction is 0, so means this term will become 0, because if force is 0, acceleration is 0. Why? F is equal to mass into acceleration. So I say, in this particular case, initial velocity, final velocity in x direction is equal to initial velocity in x direction. Guys, if this is u, what is the velocity initially in x direction? That is u cos of alpha. If this is v, what is this velocity in x direction? That is v cos of beta. Here angle is beta. And it says that initial velocity in x, that is this, is equal to the final velocity in x. So I can say u cos of alpha is equal to, I can say v cos of beta. So can I say in this particular case, u divided by v will be equal to cos of beta divided by cos of alpha. Cos of beta divided by cos of alpha. So now put over here. So I can say K1 divided by K2 will come out to be. Instead of u by v, what will we write? We say cos square of beta divided by cos square of alpha. So let's check for the options. Cos square of beta divided by cos square of alpha, that is option. Guys, please tell me in the chats if this is crystalline clear. Please tell me in the chats if this is crystalline clear. I need the signal in the chats. I need the signal in the chats if this is crystal clear to each and every single student. I would want you guys to tell me. Everyone means everyone. Why is this turning to red? Just a second, guys. I need to check the settings. Just a second, guys. Okay, now, let's take a look at this particular question. How u cos theta is equal to v cos theta? Because I told you over here, v is equal to u plus at. Acceleration in x direction is 0. This becomes 0. So vx is equal to ux. Now what is this? If this is u, this is the initial velocity in x direction. That is ux. You either call it ux or u cos alpha. It's one and the same thing. This is v. This is what we call vx, velocity in x direction. This will be vy. This will be uy. Now see. This was the question asked in AIPMT 2015. Find the force of attraction in terms of CV and D. Here in the question, you are given a parallel plate capacitor. Its capacitance is C. Okay, its separation is D and potential difference is V. You guys are supposed to tell me, what is the force of attraction? Guys, see, we say as force is equal to q square upon 2a epsilon naught. This is the force. But here, capacitance is given, potential difference is given, and separation is given. So I can say here as q is equal to c into v. So instead of this q, I'll write over here, that is, instead of q, I'll write c square v square upon, and we say 2a epsilon naught, 2a epsilon naught. Now, guys, so can I say in this particular case, force will come out to be, that is, cv square divided by 2a epsilon naught, because one c I'll write over here multiplied by c, and instead of this c, I can write this is epsilon naught a divided by, we say, d. Now this epsilon naught a will cancel, so force will come out to be, that is, cv square divided by 2d. Now see, guys, this is the formula of the force between the two plates in terms of cv and d. In the formula, you have got c, v, and d. So this is the answer of this particular question. Next, this was the question asked in NEET 2018. I hope this is visible. See, the electrostatic force between the metal plates of an isolated parallel plate capacitor having charge q and area A. It says that we have a parallel plate capacitor, okay? Its charge is q and area is A. You guys are supposed to tell me which. First of all, if you have given the charge and area A, what will be the force between the plates? Sir, force will be, that is, q square upon 2a epsilon naught. It depends in question what is given. It depends in question. See, here cv and d is given. So we say in this case, we take the force as cv square by 2d. But when in a question, we say q is given, area is given, so we take this formula. Now in this formula, does force depends upon the distance? Does force depend? Is there any distance dd? Can you see the d over here, separation? No. So we say it is independent of the distance between the plates. But if it was given cv and d, then we say it is dependent. Here it is independent. Why? Because q and a is given. Q and a is given, independent of the distance between the plates. Is this clear? Is this clear? So we say option A is the correct option in this case. Great. Next, take a look at this question. Take a look at this question. Take a look at this question. See, energy per unit volume for a capacitor. Energy per unit volume for a capacitor. Let me rewrite over here. Energy per unit volume for a capacitor having separation D capped at potential difference V is given by. We are supposed to find the energy density. Guys, see. As energy per unit volume means energy density. As when it comes to the energy density, when it comes to the energy density, or we say energy per unit volume, energy per unit volume. So we say this is equal to, what is the formula for this? We say, sir, sigma square divided by 2 epsilon naught. If you remember, recently we got it. We can also write it something like this, sir. That is E divided by U, E divided by volume V. What is V? That is A into D is equal to, that is sigma square divided by 2 epsilon naught. Okay, okay. Now, in this particular case, what we are supposed to do is, we have to find this energy per unit volume for a capacitor having separation D and we say potential difference V. So I can say, let's call this term as U dash or E dash, okay, energy per unit volume. So I can say in this particular case, E dash is equal to, see guys, what is the value of sigma? We say, sir, it is Q divided by A. So I'll write Q square upon 2A square into epsilon naught. Okay. Now guys, in this particular case, what I want you guys to do is that I want you guys to multiply over here. I want you guys to multiply over here with that is epsilon naught and divided by epsilon naught over here. If you multiply with the epsilon naught and if you divide it with the epsilon naught over here, we are supposed, okay, just do, we are not supposed to find it with in terms of electric field. Just simply, can I say in this particular case, this will be Q is equal to, that is C into V. So I say this is C square into V square upon, we say this is 2A square into epsilon naught. Okay. Now guys, can I just write this as E dash is equal to, first I wrote over here, this energy is simply, that is E, don't write E because it will confuse you. Just write over here U only. This is U dash, and this is U. Energy per unit volume. And now, what I want you guys to do over here is, we say this is U dash is equal to, guys, see, keep this over here, that is V square upon, we say 2A square into epsilon naught, and then the C square. C is the capacitance of a parallel plate capacitor, that is epsilon naught A divided by D, and it is square because it is C square. Instead of C, I am writing this. Now guys, can I say this A square and this A square will cancel over here? Okay. So I'll write over here U dash will come out to be, and this square, this epsilon naught will cancel over here. This is V square into this epsilon naught divided by, this is 2D square. I guess this is coming out to be the option. I guess this is coming out to be the correct one. Is this clear? Please tell me in the chats. Is this clear? And don't get confused with this A and D. This is energy per unit volume itself. Ignore this. Right directly. This is U dash. U dash is equal to this. And what is the formula of U dash? Energy, total energy divided by total volume. So now see, this is the energy density in terms of potential difference and separation. In terms of separation, D. In terms of potential difference. This is the energy per unit volume in terms of sigma. Guys, it depends. In a question, what the questioner is asking. If he is asking you to find the energy per unit volume in terms of sigma, you will use this. If he is asking you in terms of V and D, then you will use this. It completely depends upon you. Now, guys, let's take a look at this question. This is also a good question that we have. Uniform electric field between the plates is E. You have got the parallel plates of a capacitor over here. You have got the plates of a parallel plate capacitor over here. This is one plate, and you have got this as another plate. Okay. Let's suppose charge on this plate is E, positive, Q, and charge on this plate will be obviously negative. Okay. And guys, always remember, electric field is set up from positive charge to negative charge. Okay. Because of the positive charge, electric field is away. Because of the negative charge, electric field is towards. Now it says that uniform electric field is set up between the plates, that is E. E is the electric field. And could you please tell me what is the value of this electric field? Guys, see. This is a conducting plate. Because of the conducting plate, and because of this here, electric field will be electric field due to positive plate. Because of this, electric field will be electric field due to negative plate. And it will be towards that plate. This will be towards this. And what will you say, sir? How much is the net electric field? That is electric field due to positive plate plus electric field due to negative plate. And I can say over here, electric field due to positive plate. That will be simply sigma divided by 2 epsilon naught. Because of the conducting plate, it is sigma by 2 epsilon naught. And I can say over here in this particular case, because of this, it is sigma divided by 2 epsilon naught. And I can say, can I say over here, guys, sigma by 2 epsilon naught, sigma by 2 epsilon naught, how much this will come out to be? That is sigma divided by epsilon. This will come out to be the electric field over here. This will come because this plus this will come out to be the electric field over here. Now guys, see. If you have got these two plates, because of this plate, electric field is sigma by 2 epsilon naught. Because of this plate, electric field is sigma by 2 epsilon naught. So if you add them, it will become sigma by epsilon naught. Half plus half is 1. Now, further it says that, and having the area A, area of the plates is A, separation is given as D. Find the energy stored. Find the energy stored. Guys, see. You say, sir, I'll use the formula over here. Energy stored is equal to Q square by 2C. No. As I told you, it completely depends what is given in the question. If in a question, they are given that area is given, separation is given, how are you supposed to use this particular formula? Electric field is given. So you will have to find the energy in terms of area. We say separation and electric field. So can I say in this particular case, as, guys, tell me how much is the total energy? As we say, total energy formula we have already studied, E is equal to, that is sigma square upon 2 epsilon naught, then we say A into D. Sigma square upon 2 epsilon naught, A into D. Okay. So this is also the energy, total energy stored in a capacitor in terms of sigma. Already I have told you this. Okay. Now guys, tell me one thing. If I want you guys to multiply over here with epsilon naught and divide with epsilon naught, so can I say this becomes U is equal to, so this becomes sigma square divided by, this is 2, epsilon naught into epsilon naught becomes epsilon naught square. And then we say AD into epsilon naught. Okay. Now tell me one thing, guys. Sigma by epsilon naught is the electric field. And electric field is given as E. So I can say U is equal to, instead of sigma by epsilon naught, first we have 1 by 2, this 1 by 2. And sigma by epsilon naught, I'll write, sir, E, electric field. And electric field over here is, sir, it is square, so it is sigma square by epsilon naught square is this. So I'll take this over here square. Sigma by epsilon naught is equal to E square. And then we say A, and then we say D, and then we say epsilon naught. How many of you guys understood this particular problem? How many of you understood this particular? So this is the energy stored in a capacitor in terms of electric field. See, in a question, electric field is given, area is given, and separation is given D. These are the best questions, guys. I am telling you, perfect. Because I am making you, these are the pure conceptual questions. I am making you understand whatever is given in the question, you have to make the result, you have to make the answer in those only. Guys, give me the signal. Hey, U is the energy, guys. U is the energy stored in a capacitor because I have already discussed it over here. See, E is the where E is the total energy stored in a capacitor. Either you call it E, either you call it U. Arey, yeah. It's one and the same thing, guys. Either you call it U, either you call it E. It's one and the same thing. Energy per unit volume. If I say total energy is U, you put over here U. EU, EU. Now, guys, now, guys, now, guys, now, guys. Let's talk about a concept that's what we call the battery. This is important. We'll have to repeat it in the current electricity chapter also, but here also we need to understand this. See, guys. I would want you to... No. I'll give you the break at 8 o'clock, okay? 8:20 will be the break, or 8 o'clock will be the break. I would want you guys to focus till over here. Till then, focus over here. Eight o'clock will be taking the break. 8 o'clock, exactly. Now see, guys. Now see, battery. We say, what is this battery? As I told you, the work or the job of the battery is to do work done. The job of the battery is to do work done. Okay. I have already discussed this. How battery does the work done? When we connect a battery to the capacitor, it takes the charge from one plate and places onto the another plate. That's how it does the work done. Now guys, focus completely over here. Focus completely over here. The job of the battery is to do work done. When it comes to the symbol, we say the symbol of the battery is something like this. Okay. This is the symbol of the battery. So what battery? You take the battery, you go to the market and you buy the cell over cell. Either you call it the battery, you call it the cell. You buy the battery. For what purpose you get the battery? Sir, so that we can light up the bulbs in our room. Okay, you can do that because battery has got the energy in it. Now, this is what we call the positive terminal of the battery. This bigger one line is the bigger. This is what we call the negative terminal of the battery. Or you also call it higher potential. Higher potential. And you also call this as lower potential. This is higher potential and this is lower potential. Or you call it the positive terminal and you call it the negative terminal. This is at higher potential, this is at lower potential. Okay. And many a times in the books, you might have seen, if we have a battery over there, it is mentioned this 20 volts, 30 volts, 40 volts. What is this 20 volts which is mentioned over here? This is what we call the potential difference. This 20 volt which is mentioned is called potential difference. Or we say EMF. Later on we'll discuss that. As of now, you just remember it, potential difference. Okay? Yes. And guys, one more thing. If I say over here, this is the positive terminal, this is the negative. If I say this is the line, this is the wire over here, this is the end of the wire. Let's suppose this is the point A. And this is another end of this battery. This is what we call B. This end also has potential. This point has potential. Battery, this has got potential difference. Let's suppose if I say this point has got potential VA. It can be anything, 20 volt, 30 volt, depends. This point has got the potential VB. Always remember that this higher potential minus lower potential, we say VA minus VB, higher minus lower, keep that thing in your mind, will be always equal to this delta V. This potential minus this potential is always equal to delta V. Higher potential minus lower potential will be equal to the potential difference. Okay. Let's suppose if I give you a question over here. Let me give you the question over. Example. My dear friends, let's suppose I say I have got a battery over here. This battery has got potential difference of 20 volts. This point has got VB, its value is 0. And I am asking you, what is the potential of this end? What is the potential of this end? See guys, see. I say, recently we studied, sir, VA minus VB is equal to, sir, delta V. Here, delta V is given as 20. So I can say VA minus VB. What is the value of VB? That is 0, is equal to delta V. Delta V is given as 20. Now, VA minus 0 will be 20. So VA will come out to be 20 volts. So potential of A is 20. It is not minus 20, it is plus 20. It is not minus 20, it is plus 20. Now guys, let's suppose if I ask you the question something like this. This is 6 volts. This is, let's suppose, 3 volts over here. Okay. And in this particular case, I am, let's suppose, asking you, let's suppose I give you something like this. See. Let's suppose I give you, I have got a battery over here. Okay. And this is 20 volts, or this is, let's suppose, 40 volts. And this end has got the potential of minus 20 volts. What is the potential V? What is the value of V? What is the value of V? Okay. Now, guys, I say in this particular case, if this is the point A, this is the point B, we say VA minus we say VB. VA minus VB is always equal to, sir, delta V. Now, I say in this particular case, VA we are supposed to find out minus. VB in this case is, we say, sir, minus 20. Because VB is given as minus 20. Is equal to potential difference is given as 40. Minus into minus is how much? Plus. So we say this is VA plus 20. If you take over there, it becomes minus again. So that is 40 minus of 20. So we say VA will come out to be, we say, plus 20. This is how we actually find the potential across the ends, Let's suppose if I give you the question something like this. This is a battery over here. Okay. And this battery has got 20 volts of potential difference. And I say, this has got, let's suppose 10 volts of potential. How much will be the potential VB in this particular? What will you do? Simply, you say, sir, VA minus VB is equal to, sir, delta V. VA in this case is given as 10. Minus VB we have to find out is equal to delta V is given as 20. Now take this VB over there. So 10 minus of this 20 will come out to be VB. 10 minus 20 is minus 10. So I say in this particular case, VB will come out to be. Now I hope you guys can solve the questions of this type. Like you guys can find out what is the potential across the ends of the battery if difference is given. Okay. I hope you would be able to solve now. Okay. Like, could you please tell me the answer of this particular question? Could you please tell me the answer of this particular question? You have got 0, you have got this VB. And this in this particular case, guys, which one is higher? This is higher over here. Always remember, we say higher minus lower. We say here what we do is, we say in this case, we say VB minus, if this is A, so we say VA. Because we say higher minus lower. VB minus VA is equal to, we say delta V. VB we are supposed to calculate minus VA in this case is 0 is equal to, this is given as 10 volts. So VB will come out to be, that is plus 10 volts. So this is okay. Okay, this is done. Okay, this is also done. This is also done. This will be over here plus 10. This is also done. Great. Now, guys, let's talk about this thing. Let's talk about this concept. Let's talk about this concept. What is that? See. We say energy, work done, charging a capacitor. Guys, this is the concept that I would want you guys to focus over here right now. See. Charging a capacitor. Guys, understand one thing very carefully. Let's suppose I say I have got a capacitor over here. Okay, this is a parallel plate capacitor. Okay. Let's suppose I have got a parallel plate capacitor over here. Okay. Now, my dear friends, in this particular case, I would want you guys to connect a battery over here to this capacitor. Which is having the potential difference V. This battery has got a potential difference of how much? That is V. Now you got to know what is this potential difference. Okay. Now you got to know what is this potential difference. And we know, sir, because of the battery, this gets charged. Let's suppose plus Q charge comes onto this one and minus Q charge comes onto this one. Okay. Now we say, sure, battery will do the work done. Your battery will do the work done. Now, that work done will be stored in the form of energy. Now, guys, we say and that work done will be, guys, I have told you in the electrostatics chapter, we say work done. How do we find the work done? Work done we can find Q delta V. Like if you remember, I told you, sir, work done is equal to change in potential energy. If you remember, sir, work done is equal to change in potential energy. Now divide the charge Q over here, Now what is this? Potential energy per unit charge. If you remember, I told you that is potential. If you divide potential energy with charge, it becomes potential. So it becomes W divided by Q. This becomes delta V. If it is delta U divided by Q, it becomes delta V. Now, W will come out to be, that is Q delta V. So this is the formula of work done. Now, if I ask you the simple question in this particular case, guys, see, C is the capacitance of this capacitor, Q is the charge on the capacitor. Can you tell me how much is the work done? As I can write work done is equal. Instead of Q, I can write C into V because we know Q is equal to CV. And what is delta V? Delta V is the potential difference over here by the battery, that is V. So we say work done comes out to be CV square. This is the work done by the battery. Okay. So I'll write this is the total work done by the battery. By the battery. As simple as that. This is the total work done by the battery. Okay. Now guys, if this is the total work done by the battery, can you tell me how much is the energy stored as we say as energy stored in a capacitor? As energy stored in a capacitor. How much that will be? We say, sir, energy stored in a capacitor is 1 by 2 CV square, because we have already proved this, already discussed this, 1 by 2 CV square. Now guys, tell me one thing. If this is the energy stored, how much is the work done? Sir, CV square. How much is the energy stored? That is 1 by 2 CV square. As we have studied, the work done is stored in the form of energy. If energy is, we say, if work done is CV square, how much is energy? Sorry, if work done is CV square, how much is energy stored? 1 by 2 CV means half of this is stored. Where will the rest half go? So we say, so only half of the work done, is stored, in the form of energy of capacitor. So where will the rest of the half go? We say rest will go in loss. Rest will be lost. So that is the energy loss while charging the capacitor. So remaining will go in loss. So energy loss while charging the capacitor. So that U loss will be how much? That is also 1 by 2 CV. Because total work done in this particular case is how much? CV square. Half of that work done gets stored in the form of energy. Half of the work done will go in loss. Guys, tell me in the chats, is this crystalline clear? Tell me in the chats, is this crystalline clear? Everyone means everyone. Great. This is important. I would want you guys to focus over here. This is important. So we got to know one thing. What is that? If you charge a capacitor with the help of a battery, we say energy is lost. Energy is lost in the process. Okay, I have given you the proof. Now let's suppose if you are given a circuit something like this. You have got a capacitor over here. And this capacitor is already charged. It is charged. Like on this, it is plus CV, or here it is minus CV. Plus CV is what? Here it is charged Q. Q is equal to CV. And here it is a minus CV. So it is plus Q, it is minus Q. Now guys, understand one thing very carefully. This is the negative terminal of the battery. This is positive terminal of the battery. See, previously here, capacitor was uncharged. When you connected the battery, then it got charged. How much was the charge stored in the 1 by 2 CV square? Now see. And how much was the loss? 1 by 2 CV square. Now let's suppose, my dear friends, I say you have got a capacitor over here. This is the one plate, another plate, and this is the negative terminal, positive terminal. Let's suppose if you connect this switch, guys, if you connect this switch, what will this battery do? This battery has got the negative terminal over here. It will occupy the negative charge on this plate. So it will occupy the positive charge on this plate. So when key is closed afterwards, we say what happens is, we say, sir, this negative terminal will occupy negative charge on this plate. Positive terminal has occupied positive charge. Now here minus CV will come, here plus CV will come. Before connecting the battery, before connecting the switch, positive charge was over here, negative charge was over here. After connecting the switch, negative charge on this one, positive charge on this one. So means battery has kind of sent the charge. See. I say, initially when you connect the switch, battery will send plus Q charge. Plus Q means Q is equal to C into V. Okay. Sorry, minus Q, minus CV, because it is minus negative terminal, it will send negative charge, minus CV. So it will send minus CV charge over here. Now this minus CV and plus CV will get neutralized. So how much is the charge? 0. Okay. Then battery will send one more minus CV charge. Minus CV means minus Q. So then that minus CV charge gets occupied over here. So how much is the charge? Minus CV. What if I ask you, how much is the charge transferred by the battery? How much is the charge transferred by the battery? Sir, battery has transferred minus CV, okay, means okay. Overall, we say, sir, 2 times of CV. If we talk about the magnitude, we say battery has transferred how much charge? 2 CV. Because of first CV, it got neutralized and another CV is occupied over here. Same on this plate, same on this plate. Guys, tell me in the chats, do you all agree? Do you all agree? Guys, tell me in the chats, do you all agree? Hit the like button if you have not liked the session yet. I would want you guys to smash the like button as soon as. Yes. Now, see. If battery is transferring the charge over here, we say here, battery is transferring the charge. So, energy will be lost. So whenever battery circulates the charge in the circuit, we say energy will be lost. Here also energy will be lost. Now we have to find the energy loss here. To find U loss. Guys. I would want you guys to remember one formula directly. Don't ask me where does this come from. This is just the conservation of energy. What is that? That is, we say energy initially. Okay. Plus. Whatever is the energy stored initially in this capacitor, plus, we say work done by the battery. This will be equal to, guys, this is also energy. So this is the energy initially. We say energy stored finally, plus we say, sir, U loss. This is energy conservation itself. This is total energy initially, total energy finally. Energy, how much is the energy stored in the capacitor initially before connecting the switch? How much is the work done by the battery? Okay, that is also stored in the form of energy. Now, that will be equal to how much charge, how much energy stored finally, plus U loss. It's one and the same thing, guys. Now, tell me one thing in this particular case. How much is the energy stored initially? We say, how much is the energy stored initially? We say, sir, energy stored UI is equal to simply 1 by 2 CV square. C is the capacitance, V is the potential difference. CV is given over here. Okay, guys, because it has got only CV. Now, when you connect the battery over here, can you tell me what is the energy finally stored? Sir, finally here it has got CV. So here potential difference is V, capacitance CC, potential difference is V. So finally also it has got 1 by 2 CV square. Okay, guys, it has got plus Q charge stored. Here also it has got plus Q charge stored. Just you have reversed the, basically now this one is negative. Previously this one was positive. And what if I ask you one more thing? How much is the work done by the battery? Also, we say also. How much is the work done by the battery? We say work done by the battery will be, that is Q delta V. That is how much is the charge sent and how much is the battery. As I recently told you, as charge sent was Q is equal to 2 CV. Already discussed. Because of first CV, this got neutralized. Because of another CV, negative charge came over here. So is there any method by which we can find the charge? Yes. To find charge transfer. See, guys, in this particular case, if I say charge transferred, this is minus CV over here, this is plus CV over here. Could you please tell me, take any of the plates over here. On this plate, how much is the charge stored? Sir, plus CV. Okay. This is charge finally. How much was the charge initially over here? That is minus CV. Okay. So we say this is charge finally. Okay. And this is charge initially. So I can say this is final charge, okay, will be equal to initial charge plus X. So from there, you will get the value of this Q as X will be the charge transferred. Okay. X will be the charge transferred. That is 2 times of CV. 2 times of CV. Now tell me how much is the work done? How much is the work done? W is equal to, we say this Q over here will be simply, that is 2 CV, because charge transferred came out to be Q 2 times CV. And what is delta V? Delta V is the potential difference over here, that is V. So I say that is V. So I say work done will come out to be 2CV square. CV into V into V will be V square. That will be 2CV square. Guys, please tell me in the chats how many of you understood till over here. Everyone means everyone. Everyone means everyone. Tell me. Okay. Students are saying how this is Q is equal to CV. See. What I'm trying to say in this particular case is, take any of the plates over here. Let's suppose let's take this plate. How much is the charge on this plate? That is minus CV. Okay. Charge on this plate is minus CV. Okay. This is minus CV. Can I say this is charge initially? This is charge initially. And how much is transferred by the battery? Let's call that X plus, we say, sir, X. Can I say this will be the total charge, this will be the total charge initially, yes, will be equal to, how much is the charge finally? Sir, finally on this charge is, we say, sir, plus CV. If you are taking this plate, initially on one plate it is CV. Finally also it is CV. Here it is, if you are taking this plate, minus CV. How much is transferred? X. Finally, how much will be, sir? This is charge, conservation of charge. Initial charge is equal to final charge. This is finally. Now tell me in this particular case, how much will be X? X will be minus CV plus, if it goes over here, so this will come out to be 2CV. And this will be the Q is the charge transfer. Where Q is the charge, where X or Q is the charge transfer. And logically also it is correct, because see, you have here it is plus CV on this plate, here it is minus CV. So this has sent one, first it has sent CV over here, minus CV. Because of that minus CV, this and this got neutralized. Then it sends another minus CV. Then that minus CV occupies over here. Now, how much charge it has sent? We said 2 times of CV. Now, tell me one thing in this case, guys. Now, put up in this particular formula, put in the formula. So, can I say, so in this particular case, U initial will be how much? That is 1 by 2 CV square. Then plus work done by the battery will come out to be 2 CV square is equal to, sir, finally energy is how much? That is also 1 by 2 CV square. Then plus we say, sir, U. Now 1 by 2 CV square, 1 by 2 CV square will go. So U loss will come out to be, that is 2 CV square. And guys, you see the fact over here, whatever is work done by the battery, all of that is will be lost. It is logically correct also. See, how much is the charge initially? 1 by 2 CV square. Energy initially 1 by 2 CV square. How much is the energy finally? 1 by 2 CV square. So whatever the work done is by because of the battery, that will go in the lost. Is that clear? So from now onwards, you'll remember that if initial energy comes out to be equal to final energy, then whatever is the work done by the battery, all of that will go will be lost. Guys, give me the signal in the chats. This is the important one. So if energy initially is equal to energy finally, then work done by the battery will be lost. Logically clear also. Great. Now, what if I ask you this question? What if I ask you this question? You have got this question over here. Tell me the answer of this particular question. See, initially, the capacitor looks something like this. The battery key is not connected. So then you connect the key. Then you connect the key. After key is connected. After key is connected. After key is connected. Tell me, guys, the answer of this one. See, find the total energy loss when the key is closed. We know how to find the energy loss. Energy initially plus work done by the battery is equal to energy finally plus, we say, sir, U loss. Now tell me in this particular case, how much is the energy initially? When it comes to the energy initially, that will be 1 by 2 CV square. Guys, here. Battery is not connected. Don't say, sir, instead of V, I'll write 2V over here. Please, no. So here it will be 1 by 2 CV square. C is the capacitance, V is the voltage, so 1 by 2 CV square. But finally, when the battery of 2V is connected over here, see, battery is connected. Here it is not connected. Even you can ignore this. When battery is connected, how much will be the energy finally? You say final energy in this case will be 1 by 2 CV square. Sir, C as it is will remain C, and V instead of V, I'll write 2V square. Sir, why did you keep C as C? Because capacitance is constant. Capacitance does not change. It only depends upon the dimensions. So whatever is the capacitance of the capacitor here, same will be the capacitance of the capacitor here. So I can say this will be how much? This will be how much? This will be 1 by 2. And this is C, 2 square is 4. That is 4CV square. 2 ones are 2 twos are 4 in this particular case. Okay. So this will come out to be 2CV square. So energy finally is 2CV square. Now let's talk about work done by the battery. We say as work done by the battery will be simply Q delta V. And what is Q? Q is the charge transferred. Charge transferred. So charge transferred. How do you find the charge transferred? Guys, see. Take any of the plates over here. Okay, let's suppose I'm taking this minus CV. Okay, this plate once again I'm taking this. Then we say minus CV is the initial charge plus charge transferred. Let's suppose it is X. So this is the initially charge will be equal to the finally charge. Finally on this plate, see the same plate over here. If you are taking this one, see the same plate over here, that is 2C. Initially on this plate it is minus CV, finally on this plate it is 2CV. Obviously, if you connect the battery something like this, positive terminal of the battery will place positive charge over here. Negative terminal will place negative charge over here. So can I say in this particular case, X will be simply that is 3CV. Now, how much will be the work done by the battery? Work done by the battery will be simply Q delta V. Q is how much? That is 3CV. Okay. And how much is delta V over here? Delta V is how much? V or 2V? V or 2V? 2V. Because now the battery is connected. So I'll say over here that is, so I can say 3 twos are 6CV square. This is work done by the battery. Now, apply in the equation first. Put all of these values in equation first. So I can say, so initially energy is 1 by 2 CV square plus work done by the battery is how much? That is 6 CV square. So I can write over here 6 CV square. Then is equal to how much is the finally work done? How much is the final energy? That is 2 CV square. That is 2 CV square plus we say U loss. Okay. So I can say this is 1 by 2 CV square plus 6 minus 2. That is 4 CV square is equal to we say U loss. Okay. Now this becomes 2 into 4 is 8. 8 plus 1 is 9. So this becomes 9 by 2 CV square will be equal to. Guys, please tell me in the chats how many of you understood this one. I hope you are liking this session, okay? I hope you are liking this session, okay? Because this session is having the amazing content. X value, sir, once again, that is confusing. Okay, my dear, listen. How to find the charge transferred? I'm saying take any of the plates over here. Let's suppose I'm taking this plate, minus CV. How much is the charge initially on this one? Minus CV. Then you say plus X. Then you say plus X. Then you say plus X. What is X? X is the charge transferred. What is minus CV? Minus CV is the charge on any plates initially. Let's suppose this plate minus CV is equal to. Now on the same plate, how much is the charge finally? 2CV. Write it over here is equal to CV. This is charge initially, charge finally. Take this over there. 2CV plus CV will be 3CV. Now I hope it is done. I hope it is clear. I hope it is clear. Now see guys. Now see guys. Let's take a look over here. Let's take a look over here. That is what we call the common potential. No, we'll take the break exactly at 8 o'clock, okay? Only 20 minutes left till 8. Now let's take a look at the common potential. Guys, in this particular case, we are given two capacitors. This is C1 and this is C2. Now we say one end of this capacitor is this. It has got the potential, let's suppose V1. Another end of this capacitor, this is the capacitor. It has one end, this one. That is, it has got potential V2. Don't you think that both of these capacitors have got one end as common? Which one? That is this VC. VC is the common end for both. V1 is the one end of C1. V2 is another one end of C2, and this VC is the common end. Whatever is the potential of this end, that is what we call the common potential. Whatever is the potential of this end, that is what we call the common potential. That is what we call the common potential. Guys, see, we say, if somebody asks you, how much is this common potential, or we also call it the midpoint potential or midpoint potential. We also call it the midpoint potential. Okay. We say, if somebody asks you, how much is the value, what is the value of this common potential? Directly, you guys remember, I don't have to derive it. So common potential will be, whatever is the capacitance of this, we say C1, and potential of this end, that is V1. Then we say plus C2 V2, C2 V2. Then we say upon C1 plus C2, C1 plus C2. The same formula we'll have to study in the current electricity also. Over there, it will be resistors. Here it is capacitor. Okay. Now. Let's suppose, my dear friends, if you are given a question something like this. This is a capacitor. This is one more capacitor. This is one more capacitor. Okay. This is C1, this is C2, and this is C3. Potential of this point is V1. Potential of this point is V2. Potential of this point is V3. And potential of this point is V. And if I ask you, what is the potential VC? This, don't you think that here, this VC is the common end? This is the common potential, yes. So we say this VC will be simply, that is C1 V1 plus C2 V2, then plus C3 V3 upon, we say C1 plus C2 plus C. Simply, this potential, this capacitance, this potential, this capacitance, this potential, this capacitance. Now we have got a question over here on the screen. I would want you guys to tell me the answer of this particular question in the chats. Everyone means everyone. Let me know the answer of this particular question in the chats. I'm waiting. Tell me, guys. Yes, -5. Guys, this is the common potential, common end. Okay, we have to find this common potential. Now, this potential is V1 C1, V2 C2, V3 C3. So here I can say VC will be simply C1 V1. C1 is how much? That is 2 microfarad, 2. V1 is how much? That is 10, 2 into 10. Then we say plus C2 V2, C2 V2. C2 is how much? That is 4, and V2 is how much? That is -50, because this is given as -50. Then we say C3 V3. Then we say plus C3 is 6, and this is 20. Then we say upon C1 plus C2 plus C3. That is 2 plus 4 plus 6. C1 plus C2 plus C3. And if you solve it, this will come out to be minus 5. Next, take a look. Take a look over here. Let's suppose if you have got a circuit something like this. Let's suppose if you have got a circuit something like this. I would want you guys to focus. Let's suppose if you have got a circuit something like this. And find VC, common potential, Q1 and Q2. What is Q1? Q1 is the charge stored in this capacitor. Okay? Q1 is the charge stored in this capacitor. I will tell you in this particular question how you can find the charge stored in a capacitor also. How you can find the charge stored in a capacitor also. Okay. Now, guys, I would want you to focus over here. See. Listen to me very carefully. If you have the question of this type, guys, I'll tell you for once and all. I'll tell you for once and all. If you have got a question of this type, we say assume 0 volt potential at a point. Assume 0 volt potential at a point. I am saying you guys assume 0 volt at this particular point. Okay? We say in this particular question, we say assume 0 volt at a point. Sir, will it create any difference in a circuit? We say it will not create any sort of difference in the circuit. So I'm assuming here. Sir, how will we get to know that at which point we have to assume 0? The more questions you solve, you will get to understand. I will show you. We have current, electricity left. Over there, we'll have to use the same concept. We have many more questions, so chill. So I am assuming 0 volt over here. Okay. Then second point, I say mark the potential of every point. Then mark the potential of every point. Now, guys, see, if this is 0 over here, potential difference is 20. Could you please tell me what will be the potential of this end? See. I have told you previously. This is 20 volts over here. This is 0. And this is VA. What will we do? VA minus VB. That is VA minus VB is 0. Will be equal to delta V. That is 20. So VA will come out to be that is 20. So if this is 0, this is 20. So this will be plus 20. Okay. Now see, guys. If this is 0, sure. Let's find out in this one. Let's make this battery over here. This is 0 volt potential. This is 10 volts. We have to find the potential of this point. Let's suppose this is VB. Guys, see. Here, 0. This means positive terminal, means this is higher potential. We always say higher minus lower. So we say higher is 0 minus lower is VB. Will be equal to VA minus VB is equal to delta V. That is 10. So take this minus over here. VB is equal to minus. So obviously it is negative terminal from this side. So this has to be minus 10 volts. So if this is 0, this is minus 10, this is plus 20. Guys, if it is a simple wire over here, always remember, if it is a simple wire, we say potential at every point will be same. So I can say if you place a load in between, then potential of this point will not be equal to potential of this point. If it is a straight wire, then we consider potential will be same. Then we say potential will be. So here also potential is, we say how much, that is 20. If this is minus 10, we say here also it is minus 10 volts. Okay. Now, guys, if this is 0, how much this will be? Obviously, this will be, we say, sir, 10 volts. We got this. Done. VC is equal to plus 10. Now, guys, tell me in this particular case, listen to me very carefully. We say, now, charge in which capacitor? 4 microfarad. 4 microfarad capacitor. charge in 4 microfarad capacitor. Let me show you. Let's take a 4 microfarad capacitor over here. This is 4 microfarad. And here this is plus 20 volts. And here we say this is plus 10 volts. Plus 20 volts and plus 10 volts. Now guys, I'm taking this. I'm writing the potential across the ends. Now, whenever you have to find the charge, always remember you use this formula. Q is equal to C delta V. Q is equal to C delta V. And I can say this Q is equal to, what is the value of C? C means the capacitance over here. That is given as 4. And what is this delta V? Delta V means higher potential minus lower potential. And which one is higher? 20 is greater than 10. So I can say that is 20 minus VC. So this will be 20 minus 10 is 10. 4 into 10 is, so Q will come out to be, that is 40 microcoulomb. Don't say coulomb. It is microcoulomb. Why? Because it is microfarad over here. So it will be microcoulomb. Similarly, I can say in this particular case also, if we take this capacitor, also charge in, we say 2 microfarad capacitor. So if I say this is the 2 microfarad capacitor, and this is, we say, sir, plus 10 volts over here, and this is, we say, sir, minus 10 volts over here, minus 10 volts. Now let's find out the charge. We say Q is equal to C delta V. So we say Q is equal to, what is the value of C? This is 2 microfarad over here. So we say C is, we say 2, and sir, higher minus lower. So that is 10 minus of minus 10, because lower is minus 10. So it becomes 10 plus 10 is 20. Okay. So 2 into 20 is, we say, sir, 40 micro. In this also 40 micro. Okay. Is that clear till over here, guys? Tell me in the chats. Is this clear till over here? Is this clear till over here? I would want you guys to tell me in the chats. Okay, let's solve this question also, then we'll take the break. Let's solve this question also, then we'll take the break. Now, guys, tell me one thing. What is the first thing that we are supposed to do? We assume the 0 volt potential at a point. Let's assume at this point. We are supposed to find potential of this point and Q1 and Q2. See, guys, if this is 0, how much will be the potential of this point? That is 20 volts. If this is 0, how much is the potential of this point? That is 10 volts. Why? 10 minus 0 is 10. 20 minus 0 is 20, higher minus lower. Now we can say this point will also have got the potential of 20. Here positive terminal is from this side. That's why I'm mentioning plus 10 over here. In this case, negative was from this side. That's why minus 10. So this point will also have the potential of plus 10 volt. Now, guys, this is not a battery over here. This is not a battery over here. This is the capacitor over here, guys. This is the capacitor. So I'll redraw this figure. I'll redraw this figure. Now, make these 3 capacitors. I'll make these 3 capacitors over here. Okay. Now, guys, what is the potential of this point? That is 20 volts. Capacitance is 5 microfarad. And this is 10 volts over here. Capacitance of this is 4 microfarad. And this is 0 volts over here. Capacitance of this is VA. We are supposed to find the common potential. Here we need to apply the common potential formula, not in the previous question. So if I use the common potential formula, what is, sir? VC, that is VA. That is C1 V1. So 5 is C1 into V1 is 20. Then plus C2 V2. C2 is 4 into, this is 10 V2 up. Then plus C3 V3. C3, this is given as 1 microfarad. Sir, C3 will be C3 V3. 1 into 0 is 0. So we don't have to write it upon C1 plus C2 plus C3. That is 5 plus 4 plus 1. 4 plus 1. Guys, this is 5. How much this will come out to be? 5 into 20 is 100. 100 plus 40 is 140 divided by 10. This and this will cancel, so this will come out to be 14 volts. So common potential is 14 volts. Now tell me, charge in 5 microfarad capacitor. So this came out to be VA is equal to 14 volt. Let's make the 5 microfarad capacitor over here. So we say this is plus 20 volt potential, and this is 14 volts potential, and this is 5 microfarad. Now, how do we find the charge in this case? We say, sir, over here, I can simply say that is Q is equal to C delta V. So Q is equal to, what is the value of C over here? That is 5. And delta V is, that is higher minus lower, that is 20 minus 14. That is 6. Q is equal to 5, 6, that is 30. 5, 6 are, that is 30. 30 microcoulomb. Similarly, if somebody asks you, how much is the charge in 4? We say charge in 4 microfarad. So I'll make this 4 microfarad over here. So this is plus 14 volts, and this is over here plus 10 volts. Okay. Now, guys, in this particular case, can I just write over here? And this is 4 microfarad. So I can say in this particular case, this is Q is equal to C delta V. So Q is equal to, what is the value of C? That is 4. Delta V is 14 minus 10. So that is 14 minus 10, higher minus lower. That is 4. 4 into 4 is 16. Q is equal to 16 microcoulomb. Similarly, you can find the charge in this capacitor also. We say, how much is, what is the time? 37. We say charge in 1 microfarad. So if I make 1 microfarad over here, this is 1 and this is 14 volts and this is 0 volts. So we say Q is equal to C delta V. C is 1, delta V is 14 minus 0. So that will come out to be 14 microfarad. Is this crystalline clear to each and every single student? I would want you guys to let me know in the chats. Guys, tell me in the chats, is this crystalline clear? Is this crystalline clear? And guys, yes, we'll take the break. And if you have not liked the session yet, I would want you guys to hit the like button. Smash the like button as soon as possible. And be back after the break. Okay. So let me write over here. This is a long break. Break till 8:40 p.m. I would want you guys to come at 8:40. Okay, this is the 40 minutes break. Have dinner, okay? I'll also have. Okay. Check. Guys, tell me in the chat, say, am I audible? So, yes, I am completely audible. I am completely visible. Ladies and gentlemen, so let's continue the journey. Okay, let's continue the journey. I think. Okay, now guys, next we have over here, that is combination of capacitor. Next we have over here, that is combination of capacitor. Okay. So I would want you guys to focus exactly over here. Okay. So combination of capacitors, what does it actually mean? What does the combination of capacitors actually mean? See. Let's suppose you have got C1, C2, C3. These are the three capacitors which are connected in series. Okay. As I have told you previously, the symbol of capacitor is this. Two parallel lines means the capacitor. Let's suppose we have got three capacitors, C1, C2, and C3. And these three capacitors are connected in series. Okay. And you might have studied previously in your class 11, 12th. That is, if you have resistors connected in series, over there you find the equivalent resistance, that is R equivalent. But in this particular case, we are supposed to find the equivalent capacitor. So I say the first thing over here is to find the equivalent capacitor. Either you call it the equivalent capacitance or you say the net capacitance. That's what we need to find out over here. Now guys, see. We say when it comes to the capacitors connected in series, always remember, we say in series combination, we say charge in each capacitor is same. In series combination, we say charge in each capacitor is same. Charge stored in each capacitor is same. Means if I say charge in this one is Q1, charge in this is Q2, charge in this is Q3. We say this Q1 will be equal to Q2, will be equal to Q3, will be equal to Q. So in each capacitor, charge will be same. Like in case of series combination of resistors, we say current in each capacitor will be same. Here, we say charge in each capacitor will be same. As simple as that. Okay. But when it comes to the potential difference, guys, remember this. We said this potential difference will be divided. We say some part of it will go in this one, that is V1, V2, and V3. Like if I say this is 100 volts, okay? Suppose I say 60 volts will go over here, 20 volts will go over here, 20 volts will go over here. So total is 100. Total is 100. Okay. Total is, we say, sir, 100. But I'll write over here, charge in each capacitor will be same, but potential difference is different. So potential difference will be different. Now, we can say, sir, this potential difference net will be simply, that is V1. Potential difference across first plus potential difference across second plus potential difference across third. Now, guys, in this particular case, I can say as we say Q is equal to C into V. Charge is equal to capacitance into voltage. Now, here I can say V will be equal to Q divided by C. Now, put in this equation. So, we say, so from this equation, can I just write over here? Instead of this V net, I can write over here Q divided by C equivalent or C net is equal to. Instead of V1, I can simply say this is Q1 divided by C1. V1 is the potential difference across this capacitor. So we'll take the charge in this capacitor divided by capacitance of this capacitor. Then we say plus Q2 divided by C2. Then we say plus Q3 divided by C. Now, guys, don't you think that Q1, Q2, Q3 all are same over here? Yes. So we can cancel them out because they are same. So here it comes 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C. This is what we call the net capacitance in case of series combination. This is how we find the net capacitance. If I talk about for two capacitors, only two capacitors in series. So if we have only two capacitors in series, in that case, I can write 1 upon C equivalent is equal to 1 by C1 plus 1 by C2. Further, I can write over here 1 by C equivalent will be, guys, see, here I'm saying 1 by C1 plus 1 by C2. So can I cross multiply? So I can say this will be C1 plus C2 upon C1 C2. Do the reciprocal. So I can say C equivalent will be simply C1 C2 upon C1 plus C2. Okay. This is what we call the equivalent capacitance of two capacitors in series combination. Okay. Now, guys, there is an important concept that we need to discuss in this one. And what is that? That is law of potential drop in series combination. Guys, see. When it comes to the series combination, we say as Q is equal to C into V. Okay. Now, I can clearly say in this particular case, we say Q divided by V. Okay. Or I can write it something like this. Q divided by C is equal to V. Okay. Now, can I say in series combination? Could you please tell me what is constant? What is same in all? We say, sir, charge in each capacitor will be same. Q. So we say Q is constant. Q is, we say, sir, same, and it is constant. Now, if it is constant, I can say this V is inversely proportional to C. So V is inversely proportional to C. What does that mean? That means, guys, listen. I am saying I am taking a formula Q is equal to CV. Now, here I am saying V is equal to Q by C. Now, in this series combination, what is same, sir? Charge Q. So I can say if Q is same, we say this Q will be constant. So V is inversely proportional to C. What does that mean? That means the one which is having the more capacitance will have the less potential drop across it. The one which is having more capacitance, that is the one with more capacitance. The one with more capacitance will have less potential drop across it. But it will be only in which combination? In series combination, not in the parallel combination. Okay? Okay. So this is what we call the law of potential drop in series combination. So we say the one with more capacitance will be having the less potential difference. Now, let's suppose I'm taking the three capacitors over here, 5, 10, and 30. We say which one is having the more capacitance in this particular case? Sir, this third. So we say potential drop across this will be less. We say as V is inversely proportional to C in series combination. Okay. Guys, in this particular case, we are supposed to find the potential difference across each capacitor. Our job is to find the potential difference across each capacitor. Here, across this potential drop will be more. Why? Because capacitance is less. Because V is inversely proportional to C. Now, guys, how to solve this question? I'll tell you the trick over here. The technique is we say let the potential drop across we say 30 microfarad, across this 30 microfarad be X. I am saying across this potential drop is X. Let's assume it. Because the one with more capacitance will have less potential drop. Now, could you please tell me what will be the potential drop across this? Guys, see. This 10 is how many times smaller than 30? Sir, 30 is 3 times bigger than 10. So we say across this potential difference will be 3x. Because the one with less capacitance will have more potential drop. Similarly, 30 is how many times bigger than 5? 6 times. 5, 6 are 30. So across this, it will be 6x. Now see, across this is what we call V1. This is what we call V2. This is what we call V3. So the one with more capacitance is having less potential difference. The one with less capacitance is having more potential difference. So I can say in this particular case, so potential drop across C2 is 3x. And potential drop across we say C1 is 6x. Now guys, in this particular case, I can say this potential plus this potential plus this potential is equal to this potential. So I can say 100 volts will be equal to this in series combination, that will be equal to 6x plus 3x plus x. Guys, this is the technique that I'm using over here. Now I can say this is 100 is equal to 6 plus 3 plus x is how much? We say, sir, 10x. Now this and this goes, x will come out to be 10 volts. So this is what we call the V3. V3 is the potential drop across third capacitor. Similarly, if you got the value of x, you can find the value of V2. Now, how much is value of V2? That is 3x. So that is 3 into 10. So that will come out to be 30x. Similarly, you can find the value of V1. That is 6 into 10. That will come out to be 60x. Sorry, 60 volts. 30 volts, 60. Now see, 60 plus 30 is 90. 90 plus 10 is 100. So 100 is equal to 100. Tell me in the chats, how many of you understood this one? Let me know in the chats, guys. How many of you understood this one? Let me know in the chats. Me, sir, me. I'll show you one more question on the same pattern. Find the potential drop across each capacitor. Find the potential drop across each capacitor. Guys, see, here you have got 3, 6, 18. What does law of potential drop say? We say according to law of potential drop. We say according to law of potential drop. What does law of potential drop actually say? Law of potential drop says that V is inversely proportional to C. The one with more capacitance will have less potential drop. Now, I can say Sir, across 18 potential drop will be less. Let's suppose across this, I call it X. How much will be across 6? Sir, 18 is 3 times bigger than 6. So 6 threes are 18. So across this, it will be 6x, 3x. Now, 18 is how many times bigger than 3? 6 times. So across this, it will be 6x. So can I say this potential plus this will be equal to 10? Because this 10 is only getting divided into 3. So I can say 10 is equal to 6x plus 3x plus x. So 10 will be equal to 10x. So x will be equal to 1 volt. Now if x is equal to 1 volts, how much will be this? So 3x will be equal to 3 volts and 6x will be equal to 6 volts. So potential difference across this is 6, 3 and this is 1. What if I give you the question something like this? Find the potential drop across each capacitor. Right now, I am not giving you the symmetrical circuit. The symmetry is missing over here. The symmetry is missing over here. Now, guys, in this particular case, we will use the law of potential drop. I am saying, what does law of potential drop say? The one with more capacitance will have the less potential difference. So 8 will have less potential difference. So let's suppose across this 8, I say it is X. Let the potential drop across 8 microfarad is X. Okay. Now guys, here, between 5 and 8, I don't see any sort of symmetry. How many times bigger, smaller? So let the potential drop across 5 be Y. Consider it Y. Whenever you have unsymmetric, something like this, then consider something else, that is Y. We say and potential drop across 5 microfarad be Y. So consider potential difference across 5 microfarad be Y. Okay. Now guys, if across this is X, if across this is Y, understand one thing very carefully. Tell me, is there anything which is common between the two? First and the foremost thing, we have to find the value of Y in terms of X. Is there anything which is common between the two? Yes, sir. What is that charge? I say charge of this is, let's suppose, Q2. Charge of this is, let's suppose, Q3. As we say Q2 is equal to Q3. Charge is same in all the capacitors in series. What is the first thing you are supposed to do? Let it be X, let it be Y. Then charge. Consider that quantity which is same. That is charge. Charge is same. How do we write charge? Sir, Q is equal to C divided by V. Sorry, Q is equal to C into V. Q is equal to C into V. Now, when we say Q is equal to C into V, what is C of this capacitor Q2? That is 5 microfarad. What is V? This is V2. This is V2. And this is V1. So V2 is Y. V2 is Y. So we say 5 into Y over here. That is C2 V2 is equal to C3 V3. Now this is 5 into Y is equal. How much is this? That is 8 into X. That is 8 into X. Now, can I say in this particular case, sir, Y will come out to be, that is 8 by 5 into X. Now you got the value of Y in terms of X. See, 8 by 5 times of X. This is 8 by 5 times of X. Similarly, and potential drop across 2 microfarad. That is 2 microfarad. Potential drop across 2 microfarad will be how much? 2 is how many times smaller, or 8 is how many times bigger than 2? 4 times. So that will be 4x. If there is no symmetry between this and this, then you can consider Z over here. So as I can see the symmetry, so I'll say 4x. Now, guys, tell me. Can I say this net potential difference is divided into 4x, y, and x? So, I can say this 10 is getting divided into 4x. That is 4x plus y. What is y? Y is 8 by 5 into x plus, and this x. So this is the net potential. So V net is equal to V1 plus V2 plus V3. Now do the cross. 5 into 4 is 20. 5 into x is 5x. And 5 into 10 is 50. So it will be, after solving, 50 is equal to 20x plus 8x plus 5x. Now this is 33. So 50 divided by 33 will come out to be x. So value of x you got. And this x is, unfortunately, that is V1. This is V. Okay, this is V2, this is V3, this is V1. Okay, so this is what you got, the value of V3. Similarly, you can find the value of V2. What is the value of V2? This is V2, this is V2. V2 is y, and y is this. That is 8 divided by 5 into x. And what is the value of x? Value of x is 50 divided by 33. Okay, 5 ones are 5, 10s are 50. So that will be 80 divided by 30. Similarly, you can find the value of V3. That is 4x. So that is 4 into 50 divided by 33. So that is 4. That will be 200 divided by. How many of you understood this? Please tell me in the chats. Give me the signal in the chats if this is crystal and clear. I would want you guys to tell me in the chats. Is this crystal and clear? Then in that case, if this is asymmetric, that's what I was saying, then consider this as Z. If you consider this as Z, this and this will be having again the same charge. Then Q1 is equal to Q2, or Q1 is equal to Q3. Once again, you can do the same thing. Next, parallel combination of capacitors. Guys, see, when it comes to the parallel combination, okay, I'll make it something like this. Let me erase it, because it doesn't look beautiful at all. So let me erase it. Now see, I'll make the parallel combination of resistors, so capacitors over here. This is one capacitor. This is another capacitor. This is another capacitor. Okay. Now we connect this with a battery. So this is C1, this is C2, this is C3, and this is battery V. Now, when it comes to the parallel combination of capacitors, I would want you guys to focus over here, guys. We said these capacitors are connected in parallel. Okay. In parallel combination, always remember, battery is directly connected to all the three capacitors. See guys. When it comes to the end of this capacitor, see, it is directly connected to battery. Another end of this capacitor is directly connected to battery. End of this capacitor is directly connected to battery. This end is also directly connected. This is also having directly connected to battery, this one. When all the capacitors are directly connected to the battery, we consider it the parallel combination. See here, the end of this capacitor is connected to the battery, but another end is connected to this capacitor. So this is series. This is not parallel. Okay. And when it comes to the parallel combination, always remember, I'll write over here, in parallel combination, we say in parallel combination, guys, Potential difference across each is same. Potential difference is same across all. Why? Because they are directly connected to the battery. Whatever the potential difference will give to this battery, this capacitor, same will be given to C1 and C3. So I can say, if you say in this particular case, potential difference across this is V1, this is V2, this is V3. So these will be equal. So we say V will be equal to V1, will be equal to V2, will be equal to V3. Also, and when it comes to the charge, guys, see, let's suppose the battery is sending the charge Q over here. We say some part of it will go in C1, that is Q1. Some part of it will go in this, that is Q2. Here it will go, that is Q3. Now, guys, when it comes to series combination, let's suppose the battery will send the charge Q that will flow through all the capacitors. So Q, 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 because it's series. Here potential charge will be different. And charge is different in all the capacitors. Charge is different in all the capacitors. So I can say, sir, net charge Q is equal to Q1 plus Q2 plus Q3. Now, can I write over here as we can say Q is equal to C into V. So can I say, instead of this Q, I can write C equivalent into V net is equal to charge in first, it will be C1 into V1 plus C2 into V2 plus C3 into V3. That is charge in third. Now tell me what is common, what is same in all, that is potential difference. So V1, this will cancel out. So C equivalent will come out to be, that is C1 plus C2 plus C. So this is how we find the equivalent capacitance in parallel combination. Okay, this is how we find the equivalent capacitance in parallel combination. Now guys, in this particular case, we discuss law of current distribution in parallel combination, law of charge distribution in parallel combination. Guys, see, in case of series combination, sure, potential difference is different. That's why we discussed about law of potential drop. How much is the potential drop in each capacitor? But when it comes to the parallel combination, here charge is different. So that's why we are discussing over here law of charge distribution. How much will be the charge in each capacitor? Here we can't define law of potential drop. Why? Because potential is same here. We say I'll write as in parallel combination. Parallel combination. Can I say, is the charge same or potential? We say, sir, V is same, potential difference. So I can say Q is equal to CV. What is same in this? What is constant in this formula? That is V. So I can say Q is directly proportional to C. What does that mean? What does that mean? That means that is the one with more capacitance. The one with more capacitance will store more charge. As simple as that. The one with more capacitance will store more charge. Now, let's suppose I give you the question something like this. The question is, you have got 3 capacitors in parallel. And in this case, here from this side, we say 100 microcoulomb charge is coming and it is entering over here. Now, in which capacitor more charge will be stored? Obviously 18 microfarad. Why? Because as we say, according to law of current distribution. Sorry, charge distribution. Yes, law of charge distribution. What does that say? That says Q is directly proportional to C. The one with more capacitance will have more charge. Now, guys, tell me in this particular case, which one will have more charge and which one will have less charge? We say, obviously, this has less charge, so let the charge in this is X. So we say, let the charge in 3 microfarad is X. Okay. And the charge in. Guys, 9 is how many times bigger than 3? 3 times. And charge in 9 microfarad be 3x. Okay. And 18 is how many times bigger than this? So here it will be 3x. 18 is how many times bigger than 3? 6 times. 6 3s are 18. So charge in this will be 6 times. And charge in 18 microfarad is 6x. Now, can I say in this particular case, see guys, can I say in this particular case, so I can say net charge will be equal to Q1 plus Q2 plus Q3. And I am saying, what is this? This is actually Q1. This is actually Q2. This is actually Q3. So I can say net charge is how much? That is 100 microcoulomb will be equal to Q1 is X, Q2 is 3X, Q3 is 6X. So this will be 100 is equal to, we say 10X, this and this will cancel, X will come out to be 10 microcoulomb. So charge stored in this is 10 microcoulomb. Charge stored in this is, we say, sir, Q2. Q2 is 6x, that is, we say 60 microcoulomb. And Q3 is, we say, sorry, Q2 is 3x. Q2 is 3x, that is 30 microcoulomb. And this is 6x, that is 60 microcoulomb. Guys, tell me in the chats how many of you understood. And you can clearly see 10 plus 30 is 40. 40 plus 60 is 100. So 100 is coming, 100 is leaving. Now. Let's suppose if we get a question of this sort. Let's suppose if we get a question of this sort. See, guys. See. Find the equivalent capacitance. See, if you ever get a question of this sort, it looks like it is connected in series. In order to solve this pattern of question, what you are supposed to do is, we say, mark the potential of each point. What is the thing that you are supposed to do? Mark the potential of every single point. If I say this point has got potential A, can I say it's a straight wire? This will also have A? Yes. Can I say here also it will have A? Yes. Sir, what about this one? Load comes in between. That's what I was explaining. If the load comes in between, we say the potential will no longer remain the same. But here the potential will be same. Here the potential will be same. If I say potential at this point is A, we say potential at this point will be also A. What is the first thing you guys are supposed to do in these pattern of questions? We say mark the potential of every single point. Then, next thing. What is this point over here? That is B. We say potential of this point is B. This will be also B. B. And this point is also B over here. Done? Yes. Then We say draw these points. Draw these points. Now, guys, how many points are in the entire combination over here? Sir, only two. Which one? A, B. A, B. Sir, what about this C? C is the capacitance. So I'm drawing these points, that is A and that is B. Guys, remember the procedure because next questions you guys are supposed to do. So can you tell me this first capacitor is connected between which point and which point, sir? A and B. One end is B, another end is A. So I'll make it something like this. Sir, this capacitor is connected between B and A. That is also what we call A and B, one and the same. This is C, this is C. Sir, this third capacitor is connected between A and B once again. So I'll make it something like this. Now, it looks like it is connected in series, but in reality, they are connected in parallel. And how do we find the equivalent capacitance in parallel combination? We say C equivalent will be simply C1 plus C2 plus C3, that will be 3C. C plus C plus C is 3C. Is this clear, guys? Tell me in the chats, is this clear? Let's suppose you have a question like this. Let's suppose you have a question like this. Now see, in this case also, what you are supposed to do is, first you have to mark the potential of every single point. You have to mark the potential of every single point. See. You have to mark the potential of every point. What is the first thing? Another question, guys. Those who are saying repeat, look at this question. I'm saying potential of this point is P. Here also it will be P. And here also this point will have the potential P. Okay. Now, potential of this point is Q. We say, sir, potential of this point will not be Q. Why? Because the capacitor came in between. Now, you have to mark the potential of these points. So mark it. So let's suppose potential of this point is X. If potential of the point is not given in the circuit, then you assume it's something. Let it be X. So we say here also it will be X. So here also it will be X. Now, how many points are in the entire combination over here? 3. P, X, and Q, So we say I'll write over here P, then I say over here X, and then over here I say this is Q. Okay. Now, when it comes to the first capacitor, okay, so I say first capacitor is connected between P and X. So I'm saying this is connected between P and X. Okay. And when it comes to the second capacitor, it is connected between P and X. So I'll make it over here. This is also connected between P. When it comes to this capacitor, third one, it is connected between P and X. So I'll connect it between P and X. So this is C, this is C, this is C. And these two capacitors are connected between the same 2 points, X and X. Whenever you see the potential across the capacitors is same or across the resistors is same, these are short circuit. So that means you have to remove them from the circuit. So ignore them and remove them. Then last one is connected between X and Q. So this is connected between X and Q. I hope you got this point. Here potential is X, here is X. So that's why I'm removing these two because it will short circuit. Now, we say these three are connected in we say, sir, parallel. So I can say this will be over here. C plus C plus C is, we say, sir, 3C. And then we have got this as C. Okay. Now, 3C and C are connected in series over here. What will be the equivalent over here? We say C equivalent in this particular case will be, guys, whenever you have the two capacitors in series, then how much is the equivalent capacitance in that case? I have mentioned it over here. If you have two capacitors in series, their equivalent capacitance is C1 C2 upon C1 plus C2 after solving. So I'll use the same formula over here. I'll use the same formula over here. So I can say that is C1 C2 upon C1 plus C2. So C equivalent in this case is, what is the value of C1? That is 3C into C. That is 3C into C upon C1 plus C2. That is 3C plus C. So I can say C equivalent in this case is, that is 3C square upon, we say 4C. This and this will cancel. So this will be 3 by 4. Answer is 3 by 4C. Yes, great. A lot of students are mentioning in the chats. That's great. Absolutely great. Next one, this one. So we say this is C, this is C, this is C, this is C. What is the equivalent capacitance in this case? What is mentioned this over? What is the equivalent capacitance in this case? Find C equivalent across AB. Find C equivalent across AB. Find C equivalent across AB. Guys, tell me one thing. First, you draw the potential of every point. This has potential A. We said this will be having the potential A. This point is straight over here. It will be having A. Don't you think across these two, we say potential is A? So they will short circuit? Yes. Now, potential here is B. Here also it will be B. Here also it will be B. Now, guys, I would want you to focus exactly over here. I would want you guys to focus exactly over here. See. If I talk about, sir, this capacitor, how many points are over here, sir? 2, A and B. If I talk about this capacitor, this is connected between A and B. So I'll make it over here, A and B. So if I talk about this capacitor, these two are also connected between, we say, A and B. So this is C, this is C. C plus C is, we say, sir, 2C. C equivalent will be 2C. Yes. Next. This was the question asked in NEET 2021. Tell me, guys, in this particular case, let's suppose this is point A over here and let's suppose this is point X over here and this is point Y over here. Whatever you call it. We are supposed to find the equivalent capacitance in this particular case. Okay, ignore this charge over here, whatever is mentioned. Ignore this charge over here. Now see. I am saying that, what is the equivalent capacitance? Guys, if I am saying over here, potential of this point is Y, don't you think that potential of this point will be also Y? Because it is similar, it is going directly over here. Don't you think that potential of this point will be over here, Y also? So don't you think that potential across this is same, so this will short circuit? Directly, one concept is applying over here. Okay. Now. How many capacitors are over here? Now, sir, 2. Across this it is X. Now, I'll redraw this figure. So it would be something like this. So this is X and this is Y. This is C and this is C. Now, these two are connected in parallel. So I can say C equivalent in this case will be C plus C, that is 2C. This was the question in 2021. Tell me the answer of this question. The total energy stored in the condenser is, I hope this is visible. Tell me, guys. See. I'll make the figure over here. These are the 3 capacitors connected over here. and then you have a battery. So this is 2 microfarad, this is 6 microfarad, this is 3 microfarad, and this is 2-volt battery. You guys are supposed to tell me what is the net capacitance. You guys are supposed to tell me what is the energy stored. What is the energy stored? Guys, see. First of all, let's find the net capacitance. These two are connected in, we say, sir, series. 3 and 6 is connected in series. Can I say in this particular case, what is the equivalent of 3 and 6? In series combination, we say C1, C2 upon C1 plus C2. So C equivalent will be, C1 is 3, C2 is 6. 6 into 3 upon 6 plus 3. So that will be 18 divided by 6 plus 3 is 9. So that will come out to be 2. So we say equivalent of these two is 2. Okay. It is 2 microfarad. Now this 2 and this 2 is connected in parallel. So 2 plus 2 is 4. So I'll make it over here, this capacitor, this battery, this is 4 microfarad, this is 2 volts. Now you have to find the energy in this particular case. So energy will be 1 by 2 CV square. Okay. Now I can say 1 by 2 CV square. C is 4. 4 into 10 raised power minus 6 over here. So option B will come out to be the option in this particular case. So I say U is equal to 1 by 2. C, that is, it is microfarad. So I can say 4 into 10 raised power minus 6 farad into V square. V is given as 2 volts, that is 2 square. Okay. Now this 2 ones are 2 twos are 4. Okay. So 4 into 2 CV square. 1 by 2 CV square. It becomes 1, that is 4. 2 ones are 2 twos are 4. 2 fours are 8. So U is equal to 8 into 10 raised power minus 6. So which one? Option C is the correct option. What are you guys saying? Okay. Is this clear? Is this clear? Tell me guys in the chats, is this clear? Sir, I can't understand the short circuit. Short circuit, if I say, if you have got a capacitor, if you have got a load, if I say potential difference, if I say here it is having 4 volt, here it is having 4 volt. If potential across both the ends is same, it means short circuit. It means charge cannot flow because there is no potential difference. Delta V is equal to 0. So if delta V is equal to 0, we say Q is equal to C delta V, C into V. If delta V is 0, so charge in this case will be 0. No charge will be stored. So it is of no use because capacitor is used to store the charge. If charge is 0, so it is of no use. So we remove it. That's why we call it short circuit. Now, Mr. Rakesh, please don't ask me once again. Is that clear? Next. Dielectrics in capacitors. Guys, see. Let's suppose, I would want you to focus over here. Let's suppose I have got over here a plate. I have got over here another plate. Can I say this is a parallel plate capacitor? Yes. We call this a parallel plate capacitor. And I'm saying that charge on this plate is positive, charge on this plate will be obviously negative. And I have told you, because of these two positive charges, they will apply the force on each other. Okay, I'll write the same thing. We say due to the opposite charges on the plates, Guys, remember, due to the opposite charges on the plates, they attract each other. They attract each other. If they attract each other, can I say, so they try to stick to each other. So they try to stick to each other. Now let's suppose if I say by any chance they stick to each other, it will no longer remain a capacitor. I'll write the same thing over here. So it will no longer remain a capacitor. Why, sir? Because when it comes to the capacitor means you have got the two plates. Between these two plates, there is some separation, there is a gap. If there is no gap, where will you store the energy? So we say it will no longer remain a capacitor. This gap between the two plates should be there. This gap between the two plates should be always there. So because of these two charges, opposite charges, force will act. So they attract, they try to stick to each other. So it will no longer remain a capacitor. But we don't want these two should stick to each other. So to overcome this problem, this problem, we use dielectrics, dielectric materials. Sir, what is this dielectric? Dielectric is basically a material. Like you have conductors, like you have insulators, similarly you have dielectrics. And this is the dielectric. This is the dielectric. So basically, you don't want these two plates to stick to each other. So what you will do is you will place a dielectric in between the plates, which will not let them to stick to each other. Okay? Now, I say in this particular case, when you place the dielectric over here, guys, see, we use dielectrics. So when dielectric is placed in between the plates, guys, understand this point. When dielectric is placed in between the plates, polarization of dielectric takes place. So what does that mean? See, we say this positive wanted to attract the negative wanted to attract the positive. Then you place the dielectric. And every dielectric has a dielectric constant, okay? It's dielectric constant ER, or relative permittivity, one and the same thing. It is K. So we say this positive charge of the plate will attract the negative charge of the dielectric. So negative charge on the dielectric will be occupied over here. And negative charge of the plate will attract the positive charge of the dielectric. That's what I am saying. Initially, they were in the random positions, but this negative attracts the positive. This positive attracts the negative. So that's what we call the polarization of dielectric. Okay. Now, if I say Q is the charge on the plates, and Qi is the charge induced in the dielectric. Is the charge induced in the dielectric. As Q is the charge on the plates, and Qi is the charge induced on the walls of the dielectric. This dielectric is a slab. It is a slab, okay? Cube-shaped slab. So we say Qi is the charge induced on the walls of dielectric. Okay. Now, how much is this Q induced? Guys, understand, this is the main point which I wanted to say. This Q induced is, that is Q is the charge on the plates. Then we say 1 minus 1 divided by K, where K is the dielectric constant. So from now onwards, if somebody asks you, if we place the dielectric in between the plates, how much will be the charge induced on the walls of the dielectric? That is Q into 1 minus 1 by K. Also, can I say, sir, this Q is equal to sigma into A. We can say charge is equal to, because sigma is equal to Q by A. So Q will be sigma into A. So I can write over here, this will be sigma I into area is A, where A is the area of the walls of the dielectric, is equal to, here I can write this is sigma into A. Then we say 1 minus 1 divided by K. This A and A will cancel. Sigma I will come out to be sigma into 1 minus 1 divided by K. This is what we call the induced charge density, charge per unit area on the walls of the dielectric. So this is the induced, charge density on the walls of the dielectric. Guys, is this clear? And this was asked in JEE Mains 2021. Directly, this question was asked. Is this point clear? Please tell me in the chats. Great. Now, guys, one more important point I just want to tell you. Let's see what happens with the capacitance when you place the dielectric. Always remember one thing. Whenever the dielectric is placed, in between the plates, always remember the capacitance of the capacitor increases by K time. Like, what I am trying to say is that, let's suppose if you have got a capacitor over here. Okay? If you have got a capacitor over here, and I am saying its capacitance is C. Now, if you place the dielectric in between these two plates, okay, this is the dielectric slab. Okay, this is one plate, this is another plate. You place the dielectric slab. It is having the dielectric constant K. Okay, so I can say its capacitance will become K times of C. C is the capacitance without dielectric. Without dielectric capacitance is C, with dielectric capacitance is K times of C. Is this point clear? Now see, this was the question asked in NEET 2022. NEET 2020, I guess. Yeah. The capacitance of a parallel plate capacitor with air as medium is 6 microfarad. It is saying that I am having a capacitor over here. I am having a capacitor over here. With air as medium means nothing is placed in between. Nothing is placed in between. Its capacitance, it is saying as 6 microfarad. Okay. And then afterwards, with the introduction of dielectric, it says that when you put the dielectric in between the plates, okay, I am putting up the dielectric in between the plates. Okay, of dielectric constant, let's suppose K. And this K means ER, relative permittivity or dielectric constant. Its capacitance C dash becomes, we say, sir, 30 microfarad. Find the permittivity of the medium. We are supposed to find the permittivity of the medium, epsilon M. Please wait and I'll tell you. First and the foremost thing is, guys, this is the capacitance without dielectric. This is the capacitance with the dielectric. Can I say as capacitance of a capacitor is, we say, K times of C if dielectric is placed. Recently calculated this. See? Now, C dash in this case is given as 30 is equal to this K. K means ER into C. C is given as 6. 6 ones are, 6 fives are. Okay. So, ER in this particular case is given as 5. We got, so means the dielectric constant of this capacitor is 5. Dielectric constant of this capacitor is 5. Now, we are supposed to find the value of EM. If you remember the marathon of electrostatics, over there I told you as this permittivity of medium is always equal to, that is, permittivity of free space multiplied by relative permittivity. If you haven't watched that one shot, then directly remember this. Permittivity of any medium is equal to permittivity of free space multiplied by relative permittivity. If you have to find the permittivity of this medium, what will you do? EM is equal to epsilon naught. Permittivity of free space is given and you know it. That is 8.85 into 10 raised power minus 12. Okay. Multiplied by ER. What is ER over here? That is, okay, 5 8s are 40. So this will be the value of epsilon of M. Please tell me in the chats, is this crystalline clear? Now, one more question I have over here in this one. Solve this question. This is your homework. This question is your homework, guys. A parallel plate capacitor with air between the plates is of having capacitance 10 picofarad. The capacitance, if the distance between the plates is reduced by half, okay, and the space between them is filled with the substance of dielectric constant 4 is. So it is saying that we have a capacitor, parallel plate capacitor, its capacitance is C. We have a parallel plate capacitor, okay. Its capacitance is given as 10 picofarad. 10 picofarad. And then it says that you take, and can I say in this particular case, this is C is equal to epsilon naught A divided by D. If I say this is the separation between the plates, this is the area A. And its value is actually given as 10 picofarad. The capacitance is given as 10. And then it says that you take this capacitor And if the distance between the plates is reduced by half, means this distance becomes d by 2. Okay. And the space is filled with the dielectric. This is filled with the dielectric. Okay. Of dielectric constant 4. You are supposed to find its capacitance. You have to find the value of C dash. It says that you have a capacitor, separation D, area A, its capacitance is epsilon naught A by D is 10 picofarad. Then, if you decrease the separation and put the dielectric in between, how much will be the new capacitance? How will you find this? C dash is equal to epsilon naught A. And first of all, when dielectric is placed, we say it becomes K times of C. Sir, K times of C, and C in this case will be epsilon naught A divided by D by 2. If I remove this dielectric, how much will be the capacitance? Epsilon naught A upon D by 2. If I put this dielectric, how much it will be? K times of epsilon naught A upon D by 2. K times of C. Now, take it over there. So, this will be K and 2 will be in numerator 2K epsilon naught A divided by D. Now, I can write over here 2. What is the value of K? K is given as 4. And epsilon naught A by D. Epsilon naught A by D is given as, we say, sir, 10. 2 into 4 is 8. 8 into 10 is, we say, sir, 80 picofarad. 80 picofarad is the answer. Guys, is this clear? Please tell me in the chats. Is this clear? Please tell me in the chats. I need the signal from every single student. Everyone means everyone. Great, great, great. Generate का one light eye. जल्दी. Now see, guys. Take a look over here. Sir, I have completed your lectures from Game of NEET till AC. Should I watch this series also? See, Dinesh, in this series, I have put up a lot of many questions and some topics I have also added over here in this series. So I would recommend you to skip all of those topics which you have already studied previously. And check which are the topics which are new over here. Even you can check those from the PDFs itself. So we put up the PDF in our Telegram channel. So you can check those PDFs and you can learn those also. Now, guys, now we need to talk about insertion of dielectric when battery remains connected. Insertion of dielectric when battery remains connected. See, guys, battery remains connected during the insertion. During the insertion, battery remains connected. What does that mean? What does that mean? Guys, see. Yes. Guys, I have sent the PDF already in the Telegram group. That is Unacademy NEET English Telegram. And you can join my Telegram, that is t.me/Yawar Manzoor, YAWARMANZOOR. Okay, this is my Telegram. You can join this one also. We put up all the important information in this Telegram. t.me/YAWARMANZOOR. Now guys, focus over here. Listen to me very carefully. Listen to me very carefully. This is, I have got a capacitor over here, okay? And I am connecting a battery to this particular capacitor. Listen very carefully, okay? Is there any dielectric in between the capacitor? We say, sir, no. Let's suppose if I insert the dielectric in between the capacitor. Can I say this is what we call insertion of dielectric in between the plates? Yes. And see, is the battery connected or disconnected? Battery remains connected. So that's what we need to see over here. Before inserting the dielectric, if I say how much is the capacitance of this one, that is C. How much is the potential of this one, that is V. Charge, electric field, energy, force. Sir, when you place the dielectric, what will happen to the capacitance? Will it remain the same or it changes? What will happen to potential, charge? All of these things we have to see. Now guys, see, in this particular case, before insertion, I am saying capacitance of this capacitor is C. Before insertion, potential difference of this capacitor is, we say, sir, V. Before insertion, charge of this capacitor, charge stored because of the battery on this capacitor, and I call that Q is equal to C into V. Okay, Q is equal to C into V. Now guys, electric field, always remember, when it comes to the electric field, guys, this is the separation between the plates, okay, that is D. Okay, and we say electric field is equal to, we say V divided by D. V is the potential difference between the plates, D is the separation. So we say this electric field between the plates is equal to V divided by D. And what about the energy? Energy in this particular case is, I can simply say that is Q square divided by, we say 2C. That is Q square divided by 2C. Okay. And my dear friends, in this particular case, you can clearly see, or you can take this formula of energy, that is U is equal to, we say 1 by 2 CV square, 1 by 2 CV square. And when it comes to the force is simply, that is Q times of V. Force is simply, that is Q times of V. Okay. Yes. Now. Can I say all of these things you guys are supposed to tell me? Guys, see. All of these things you guys are supposed to tell me. We say after insertion. After insertion. You guys are supposed to tell me what will happen to the capacitance. We say, sir, capacitance after insertion becomes K times of C. Whenever you insert the capacitor dielectric, we say it becomes K times of C. Now, let's talk about what happens to the potential difference. Okay, what happens to the potential difference? My dear friends, can I say, when it comes to the potential difference V dash, it remains V only. Why? Because battery is connected. So battery maintains the potential difference. Guys, if I say you have got a capacitor over here, then you have got a 20-volt battery. We say this battery will always maintain 20-volt potential difference across the capacitor. So it will be always 20 volts. So we say potential difference will remain. Why? Because battery remains connected. Connected. Next. Charge. We say, sir, Q. We say Q dash is equal to C dash into V dash. Finally, capacitance, finally, potential difference. So I say Q dash is equal to C dash. C dash is K times of C. V dash is V. So C into V. What is C into V? C into V is Q. C into V is Q. C into V is Q. So this Q dash will come out to be K times of Q, or K times of, if you take this, Q dash is equal to K times of. So charge has increased how many times? K times. Okay. Okay, let's talk about this is the first one, second one, and this is the third one. Let's talk about fourth one. What is that? That is electric field. Guys, we say electric field will be V dash divided by D dash. What about potential difference? Potential difference remains the same, V. And separation between the plates also remains the same, that is D. So it will remain the same, that is E dash is equal to E only. Let's talk about energy. U dash is equal to 1 by 2 C dash into V dash square. So I can write it 1 by 2 C dash, that is K times of C. V dash is V itself, that is V square. So take this out, I can write U dash is equal to K times of 1 by 2 CV square. So 1 by 2 CV square is what? Initial energy. So U dash is equal to K times of U. Okay. 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 And then when it comes to the force, even you can write the formula of force as Q square by 2A epsilon naught also. Okay. You can write this as, that is Q square divided by 2A epsilon naught also. What about Q? Q is increasing. So finally I can write over here. F is equal to, F dash is equal to, that is Q dash square divided by 2A dash epsilon naught. Now area of the plates remains the same. So Q increase, Q dash is equal to K times of Q. So it becomes K times of Q, okay, over here. Okay, and so finally it becomes K times of Q. So can I say in this particular case, this will simply become how much? That is K times of, we say F times of K. Okay. Now guys, let's talk about over here. Battery is disconnected. Battery is disconnected before insertion. Okay, battery is disconnected before insertion. Guys, see, this is the capacitor over here. This is the capacitor over here. Okay. This is the capacitor over here. And in this particular case, guys, I have connected a battery over here. Okay. So before inserting the dielectric, I am saying in this particular case, what is the capacitance? That is C. How much is the charge stored? That is Q. What is the potential difference in this particular case, sir? Potential difference V is equal to Q divided by C. Q by C. Okay. Now what about the electric field? That is V divided by D. What about the energy, sir? Q square divided by 2C. What about the force, sir? That is Q into E. Q into E. Now tell me, guys, in this particular case, I would want you guys to let me know. What is that? Sir, insertion of dielectric and battery is disconnected. In the previous case, battery was connected. In the previous case, after insertion, battery is connected. But right now, battery is disconnected when you do the insertion. We say insertion, after insertion. After insertion. We will have to talk about these things. Now, guys, the very first thing, that is capacitance. So capacitance will become K times of C. No matter what, if the battery is connected, disconnected, it doesn't matter. capacitance will become K times of C. And when it comes to the charge, we say, sir, Q dash. Q dash will be Q only. Why? Because charge on a capacitor is stored because of the battery. So if let's suppose initially battery have stored 10 coulomb of charge, now battery is disconnected. Now 10 will remain over there, na? Charge will not increase. Previously battery remains connected, charge was increasing. So here in this particular case, charge remains same. Let's talk about potential difference, sir. V dash is equal to Q dash divided by C dash. So that will be Q dash. What is Q dash? That is Q, and C dash is K times of C. Now see, Q by C is V. So V dash will come out to be that is V divided by K. So potential difference has decreased by K time. Let's talk about we say electric field. E dash is equal to V dash divided by D dash. And right now, V dash, I can write V by K. So this is V by K into D. Now, V by D is what? That is old electric field divided by K. So electric field is decreased by K times. Electric field is decreased by K times. And next, we say energy 1 by Q square by 2C. That is Q square divided by 2C. So this is U dash, Q dash, C dash. So can I say in this particular case, what is Q? Q is same, that is Q square divided by 2C. So it will be 2 times of K times of C. Because C dash is K times of C. So here I can say U dash is equal to Q square divided by 2C, and this is K. So Q square by 2C is the initial energy. So we say U dash becomes U divided by K. Similarly, if you talk about the force, F dash is equal to Q times of E. Okay, Q times of E. We say charge Q dash, E dash. So charge remains the same, that is Q. Electric field, what happens with the electric field? That becomes E by K. E divided by K. So force becomes F by K. Is this clear? Please tell me in the chats. Is this clear? Great. This is a small chapter. This is a small chapter. Now it will take us maximum it will take us 1.5 hours. We'll get done by 12 o'clock. Most probably we'll get done by 12 o'clock. Sir, how to solve questions with speed? Shoo! That's how you can solve the question. Okay. Ho 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 ho. So guys, tell me something. Where are these lovebirds? Every time they come in the chat. Okay. I don't see anyone today. Come on, guys. They are roaming. Okay, break up. Huh? Okay, okay, okay. They slept, I guess. They left. At least I was getting the likes from those lovebirds, huh? Yeah. How to revise previous lectures? What kind of questions you are asking, guys, huh? How to revise previous lectures? Just open up the previous lecture and revise. The last year, the capacitor was completed in 5 hours. That's why I kept telling you I have added so many more questions. You can feel the difference if you compare the last year's one shot with this year's one shot. Okay, there is a difference. Every single year, there has to be something new. Okay. Yes, I'm done with my dinner. Now, guys, come on. Back to business, back to business. Now, guys, see. Series combination of dielectrics. Understand one thing. Till now, I was saying that I have got the parallel plates and I was filling these parallel plates with a dielectric. And this dielectric was taking the whole space over here between the plate. It was taking the whole space between the plates. Okay. But right now, my dear friends, I have placed a dielectric between the plates. This is the dielectric between the plates. But this dielectric is of the width T only. It has the width T only. And separation between the plates is given as D. Okay. And this has the dielectric constant K. You guys are supposed to tell me what is the capacitance of this capacitor after placing this dielectric. We say, I'll write over here. As okay, as dielectric is placed in a capacitor. So its capacitance will change. Dielectric is placed in a capacitor, so its capacitance will change. We know whenever you place the dielectric in between the plates, its capacitance changes. If it is in the entire, we say, area, then in that case, we say it is K times of C. Oh, okay. Now, guys, when it comes to the capacitance of this one, we say C is equal to. I would want you guys to focus and remember directly. That will be epsilon naught into A. What is A? A is the area of the plates. Epsilon naught A upon. Then we say D minus T. There is a long derivation for this. D minus T. T is the separation between the plates. T is the width of the dielectric. Then we say plus T divided by K. Then we say plus T divided by K. T is the width, K is the dielectric constant. This is the capacitance of this capacitor, in which the dielectric slab is placed, which is having the width T. This is dielectric slab. which is having the width T. This is its capacitance. Now, what if I ask you the question, when the dielectric is replaced with air, it is saying that if we replace this dielectric with air, means if we place a dielectric over here and which is made up of air, we say for air dielectric constant is 1. If this is air, we say its dielectric constant is 1. Remember, for air it is nothing, it is air means nothing, so we say its dielectric constant is 1. Let's use the same formula. We say C is equal to epsilon naught A upon T minus T plus T by K, T divided by 1. Instead of K, I'll write 1. Now, this plus T minus T will cancel, so it will come out to be epsilon naught A divided by D. Correct? Because this is clear. If you put K is equal to 1 means air, and without dielectric, we know its capacitance is epsilon naught A by D. Either you say it is without dielectric or you say a dielectric of air. So capacitance comes out to be epsilon naught A by D, which we know already. When dielectric slab is very thin, means if you have got a dielectric slab which is very thin, okay, like this is the dielectric slab. This is the width over here between this, that is D, and width of this T is almost equal to 0. It is very thin. Let's check its capacitance. C is equal to epsilon naught A upon T minus T plus T divided by K. T minus T plus T divided by K. We say. He can't say anything. Now he says, we say. Alia Bhatt's brother, huh? Not in my chat, huh? Not allowed over here. Now, guys, focus over here. So we say in this particular case, if we say T is equal to 0, width is extremely small. Okay. So what is the general formula? General formula over here is, we say, sir, C is equal to epsilon naught A upon D minus T plus T divided by K. And if I say over here, this T is equal to 0. So this becomes 0, this becomes 0 in this particular case. So I can say here also, this will come out to be T divided by K. This will come out to be epsilon naught A divided by T. Epsilon naught A divided. Okay. Okay. Only Kashmiris can understand. Now, guys, let's move on to when dielectric is a conductor. Let's suppose I have got over here the plates Okay. And I'm saying in between these plates, I'll place a dielectric which is having the dielectric constant. Okay. If it is a conductor, it will have the dielectric constant infinity. We say for a conductor, we are taking the dielectric constant as infinity. Now, in that particular case, what will be the capacitance? I'll use the general formula, that is epsilon naught A upon T minus T plus T divided by K. D minus T plus T divided by K. Now guys, in this particular case, I can write over here epsilon naught A upon T minus T, T by K. K is what? Infinity over here. ER is infinity, K is infinity. So this becomes 0, so it will become D minus T. This is the this is the dielectric on, this is the capacitance of a capacitor in which dielectric is placed as the conductor. Conductor is placed as the dielectric. Okay. Now guys, focus over here. Now we have this. Let's suppose if you get a question something like this. And in this particular case, see guys, you have got the plates. This is a capacitor and here two dielectric slabs are present. One slab is this one, another slab is this one. This slab has the dielectric constant K1. This slab has a dielectric constant K2. Okay. And the width of this slab is given as, we say, D1. And the width of this slab is, let's suppose, given as D2. This width is given as D2 and this width is given as D1. We are supposed to find the capacitance in this particular case. We say here, capacitance will be, guys, if you have multiple dielectrics, more than one dielectrics, in that particular case, I can say capacitance will be simply epsilon naught A upon. A is the area of the plates, A upon. Then we say that is D1 divided by K1 plus we say D2 divided by K2. What is D1? D1 is the width of this slab and K1 is the dielectric constant of this dielectric. And D2 is the width of this slab and K2 is the dielectric constant of this dielectric. Okay, so this will be the capacitance in this particular case. And one more thing, if I ask you, let's suppose if you have got the dielectric slabs connected something like this. This is what we call the slabs in series. Okay, slabs in series. Dielectric slabs in series. Okay, and in this particular case, if you are supposed to find the capacitance, so you simply say epsilon naught A upon. Then we say D1 divided by K1. D1 is the width of this one. K1 is the dielectric constant of this one. D2 is the width of this one. K2 is the dielectric constant of this one. And D3, K3, D4, K4. Similarly, I can write D2 divided by K2 plus D3 by K3. Then we say plus D4 divided by K4. I can write it something like this. Now. One more thing I would want you guys to understand. What is that? Yawar sir on his mission to complete the chapter. Yes. So, one more thing I would want you guys to understand over here. What is that? See, if you have got multiple dielectrics in series, okay, and you are supposed to find the equivalent dielectric constant, like previously you used to have multiple capacitors connected in series and you are finding the equivalent capacitance over there. Same is the case over here. If you have got multiple dielectrics in series and you are supposed to find equivalent dielectric constant, so you are supposed to find equivalent dielectric constant. Let me show you how. See guys, let's find the equivalent dielectric constant. Let's find the equivalent dielectric constant. See guys, I am saying that, can I say this is the capacitance of this capacitor after placing the dielectric? Yes. Guys, see, we have placed multiple dielectrics and this is the capacitance of this capacitor after placing the dielectrics. Yes. And we know we know after placing the dielectric, after placing the dielectric, we say capacitance becomes K times of C. We say capacitance C dash becomes, we say K times of C. Sure, what is this? This is also C dash. Why am I calling this C dash? Because this is the capacitance after placing the dielectric. This is also the capacitance after placing the dielectric. And it is K times of C here in this particular, this is the general formula. And this is the formula in this particular case. Now, can I say both of these are equal? Okay. Here C dash. Now this is equal to this. So can I say, let's call this as equation first. Let's call this as equation second. So I say from first and second, I can simply say in this particular case, instead of this, I'll write that is K times of C is equal to, that is epsilon naught A upon, that is over here D1 divided by K1 plus D2 divided by K2 plus D3 by K3 plus D4 by K4. Now guys, tell me one thing. What is this C? C is the capacitance of the capacitor without dielectric. Like, this is the capacitance of the capacitor with the dielectric, and that is K times of C. And this C is the capacitance of the capacitor without dielectric. So instead of this C, I'll write epsilon naught A by D. So I say this K equivalent into epsilon naught A divided by D is equal to. So I can say from this one, this is epsilon naught A upon. So this is epsilon naught A upon. Then we say D1 by K1 plus D2 by K2 plus D3 by K3, then plus D4 by, we say K4. Now, this epsilon naught A will go and it goes over there. So K equivalent in this case will come out to be D upon, we say D1 by K1 plus D2 by K2 plus D3 by K3 plus D4 by K4. So this is the value of K equivalent in this particular case. K equivalent and C is different over here. C is the capacitance of this capacitor after placing the multiple dielectrics. Okay. And K equivalent is the equivalent dielectric constant. Equivalent dielectric constant means if you replace all of these with a single dielectric constant, that would be this K. That would be this K equivalent. Guys, tell me in the chats if this is crystalline clear to each and every single student. Okay, ignore Wasim, but tell me in the chats, is this crystalline clear to each and every single student? Okay, great, great. And do like this session if you have not liked the session as of now. Okay. Okay, okay, okay. It's gonna be okay. Now, guys. Let's take a look over here. Now we have got a question. This question was asked in JEE Mains 2021. I would want you guys to solve this question over here. See. In this question, you have got a capacitor. You have got a capacitor. You have got a capacitor in which multiple dielectrics are placed. This is having the dielectric constant K, and this width is D. Then you have got the next dielectric constant. It is having 3K. Okay. And this is having the width 2D. Okay. And then you have got the third dielectric over here. This is having the 5K dielectric constant and this width is 3D. We are supposed to find out the capacitance of this capacitor. Whenever you have the dielectric constants in series, how can you find the capacitance? C is equal to. That is the formula that I have gave you over here. Epsilon naught A, D1 by K1 plus D2 by K2 plus D3 by K3 and so on. So I'll use the same formula because dielectrics are placed in series. So I can say this is epsilon naught A upon, then we say D1 by K1 plus we say D2 by K2, then we say plus D3 divided by K. So I say this will be epsilon naught A upon D1. D1 is the width of first dielectric, that is D divided by K, plus width of this is 2D divided by 3K, then plus width of this is, we say 3D divided by 5K. Okay. And I can say this C is equal to, that is epsilon naught A upon D divided by K. We can take common. In here we have 1 plus 2 by 3 plus 3 divided by 5. Okay. Okay. And it comes out to be 34 by 15. So this will be epsilon naught A upon. So we say D and K, take it in the numerator. So it is K over here. And this will come out to be, that is 34 divided by, we say. And I can write this as 15 divided by 34. And then we say epsilon naught A divided by D. Option A is matching over here. Option A is matching over. Next question we have got. Okay. This one. And let me show you this. Let me show you this over here. This was also asked in the JEE Mains 2021. See, guys, you have got the parallel plates. Okay. And it says that a dielectric is placed of dielectric constant K in the width of 3D by 4. This width between the plates, this separation is given as D. And in this separation, we have placed a dielectric slab, which is having the width of 3D by 4. Okay? Which is having a width of 3D by 4. And can you tell me how much will be this width? This width will be D divided by 4. Okay, if you read this out, it says that we have got a capacitor in which a dielectric is placed, which is having the width of 3D by 4. Okay. Okay. 3 by 4D. 3 by 4D. Okay. And this will be D by 4. D minus 3D by 4 will be D by 4. And this is having the dielectric constant K, and obviously this will be air over here. We are supposed to find the capacitance of this capacitor. How will we find? Once again, we use the same formula. Epsilon naught A upon, we said D1 divided by K1 plus D2 divided by K2. So I can write over here C is equal to epsilon naught A upon D1. D1 is 3D by 4. 3D divided by 4. Divided by K1. K1 in this case is given as K. Then we say plus. We say D2. D2 in this case is given as D by 4. And K2 in this case is 1, because for air K is 1. Now, sure, you can take common as this is epsilon naught A upon. What will you take common? That is D by 4. D by 4 you can take common. In this, it will be 3 divided by K plus, we say, sir, 1. So further you can write C is equal to, that is epsilon naught A divided by. Now, you can write over here, this is D by K, and then K into 1 is K, 3 plus K by K. 3 plus K divided by K. This is 4 over here. This is 4 over here. Now take this in the numerator, it becomes epsilon naught A divided by D, and over here it is 4K. Okay, and then it becomes 3 plus K. Then it becomes 3 plus K. Now guys, epsilon naught A by D, it says that epsilon naught A by D is the capacitance of a capacitor which is without the dielectric, and it has basically asked to take this as C naught. Take this as C naught. So I can say this C will be equal to, instead of this I'll write C naught 4K upon 3 plus K. So option which is correct? 4K C naught 3 plus K. Option A. Guys, tell me in the chats if this is crystal and clear. Everyone means everyone. We'll take the break at 11. 10:34 right now. Or let's take the break, huh? Let's take the break at 10:40. 10:40 we'll take break. Now guys, see. In this particular case, parallel combination of dielectrics. Parallel combination of dielectrics. Guys, see. Here, in between the capacitor, you have got K1, you have got K2, you have got K3. Okay. And this width is given as A1, A2, A3. Now, these are the 3 dielectrics which are placed in parallel over here. Now, if you have the dielectrics in parallel, if dielectrics are placed in parallel to each other. If dielectrics are placed parallel to each other, if dielectrics are placed parallel to each other. So we say in that particular case, capacitance would be C is equal to, we say epsilon naught divided by D. What is D? D is the width or separation between the two plates. Okay. This is one plate over here. This is another plate over here. And then we say A1 into K1. A1 is this width, K1 is this dielectric constant. Then plus A2 into K2, then plus A3 into K3. This is what we call the capacitance of the capacitor, in which dielectric slabs are present in parallel. In which dielectric slabs are present in parallel. In which dielectric slabs are present in parallel. Okay? In which dielectric slabs are present in parallel. Now guys, in this particular case, I would want you guys to focus exactly over here. Everyone means everyone. See guys, this is the capacitance of a parallel plate capacitor when the slabs are in parallel, okay? One after the another. When it comes to the series, we say epsilon naught into A upon A1 K, A D1 by T, K1 plus D2 by K2 plus D3 by K3 and so on. This is we say in case of parallel combination. And when it comes to equivalent dielectric constant, also, let's find out equivalent dielectric constant. Also, let's find out equivalent dielectric constant. That equivalent dielectric constant will be C is equal to, we say guys C, we say, can I say as we know, once again I use the same logic. Capacitance after dielectric, C dash is equal to K times of C, which is equal to K times of epsilon naught A divided by D. So this is also C dash, this is C dash. Why am I calling this C dash? Because this is the capacitance of this capacitor after these dielectrics. And this is the capacitance of the capacitor after dielectric. This is the general formula. This is the specific formula. So we say, call this as equation first, call this as equation second. So I can simply say, so we say from first and second, can I say this epsilon naught A divided by D? I'll write over here. Epsilon naught A divided by D, this will be equals to epsilon naught by D. We say epsilon naught divided by D, A1 K1 plus A2 K2 plus A3 K3. Now epsilon naught by D will cancel out over here. Okay, and over here it was K equivalent. So K equivalent will come out to be, that is A1 K1 plus A2 K2, then plus A3 K3. Then we say whole divided by E. So this is the equivalent dielectric constant. This is the equivalent dielectric constant in case of parallel combination. Means if you have the dielectric slabs connected in parallel, and if somebody asks you to tell me the equivalent net dielectric constant, then in parallel combination, this is the answer. Let's check. (10:40). Let's take the break till 11. Break till 11. Am I audible, guys? Tell me. So, let's take a look at this question. Let's take a look at this question that we have on the screen. Okay, before this, let's solve this. Let's solve this one. So in this particular case, we are supposed to find out what is the equivalent capacitance. What is the equivalent capacitance? If you have the two dielectrics placed in parallel. If you have the two dielectrics placed in parallel. Guys, whenever the dielectrics are placed in parallel, how you are supposed to find the equivalent capacitance? We say C dash is equal to epsilon naught divided by D. Then we say A1 K1 plus we say A2 K2 plus A3 K3 and so on. Okay. Now, in this particular case, I can write over here C is equal to epsilon naught by D. Then we say A1 by A1 K1. A1, this is air over here. So means in this particular case, value of K will be 1. So what is the value of A1? A1 in this case is A by 2. So I'll write over here A by 2. K1 is 1. So I'll write A by 2 only. Then we say plus. A by A2 K2. What is A2 over here? That is A by 2. So this will be A by 2. And what is K2 over here? That is, I can simply say K. Okay. A2, K2. Now, can I say in this particular case, I'll write epsilon naught A. Okay. I'll take this A by 2 as common. So epsilon naught A divided by 2D. And then I'll write 1 plus K over here. Now, epsilon naught A divided by D. This is the capacitance of a capacitor without dielectric. So I can say in this particular case, that is C dash will come out to be C divided by 2, 1 plus K. So I guess option 1 is matched. Now let's take a look over here. Let's take a look over here. See guys, you have got multiple dielectrics placed in series. Sorry, placed in series and parallel. This is a mixed combination. You are supposed to check which of the following options is correct over here. Guys, there is a trick over here. Use this trick. Use this trick. What is that? See, we'll use this trick first in this question. What is the trick? If I say, my dear friends, let's suppose I am saying that we are assuming over here it is air also. Let's assume this dielectric constant is over here air also. This dielectric constant is made of air. Let's assume that. So its dielectric constant will be 1 then. This is also 1, already 1. Could you please tell me if this is 1, what will be the equivalent capacitance, sir? If this is made of air, we say the capacitance, new capacitance, C dash has to be equal to C. Because C is the capacitance when the dielectric is air or when there is nothing in between. Now, in which of the following options, if you place K as 1, C dash will come out to be C. I guess that is only option 1. In option 1, you can say C dash is equal to C divided by 2, 1 plus 1. Here, instead of K, will put 1 plus 1. So this and this will cancel. So C dash will come out to be C. What I'm trying to say is that you assume this is made of air. If this is made of air, this dielectric slab, can I say K is equal to 1? This upper part is already air. So air plus air is air. So we say now the capacitance C dash should be equal to that capacitance, which is when there is no dielectric between the capacitors or when there is air. When there is air, capacitance is C dash. Finally, also capacitance should be C dash. Now this question will give you more feel. Let's suppose if I say, if I say this K1, this is made of air, this dielectric. This is also made of air, this is also made of air, this is also made of air. If I say K1 is equal to K2 is equal to K3 is equal to K4 is equal to 1. Can I say means all of these are made of air? Yes. Now, if it is placed air in between, this is air, 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 what would be the equivalent capacitance? Then I can say K equivalent also has to be equal to 1. Because if all of these are made of air, then we say their net equivalent their net equivalent dielectric should also be 1. Do you all agree? Please tell me in the chats. Please tell me in the chats. Guys, now check in which of the following options, if you put K1, K2, K3 as 1, we say K equivalent is also coming out to be 1. This is K equivalent. This is K equivalent. This is K equivalent. This is K equivalent. Let's check in the option 3. We say in option 3, guys, in option 3, if we put K1, K2, K3 as 1, let's check what will be the value of K equivalent. We say 2 divided by K equivalent is equal to, we say 3 upon 1 plus 1 plus 1. That is 1 plus 1 plus 1. K1, K2, K3. We'll place all of these as 1. Then we say plus. We say 1 by K4. That is also 1. So 3 by 3 plus 1 by 1. So how much this will come out to be? Guys, this is 2 divided by K equivalent is equal to 3 by 3 plus 1 by 1. 3 by 3 is also 1. So 2 by K equivalent is equal to 1 plus 1 is 2. Now, K equivalent in this case will be 2 by 2. That will come out to be 1. So in option 3 only, if you put K1, K2, K3, K4 as 1, then only K equivalent will come out to be. See, in option 1, 1 plus 1 plus 1 is 3. Then 3 K times of 3. 3 plus 3 is 6. So here K equivalent is coming out to be 6. Not this option, not this option, but option C is correct option. Is this clear? Is this clear? This is the technique that you guys are supposed to use in this. Okay? Yes. Now, guys, listen to me very, very, very carefully. Let's now talk about the combination. Guys, if you have not liked the session as of now, please do like it as soon as possible. Let's talk about the combination of plates. Let's talk about the combination of plates. Let's talk about the combination of plates. Guys, see, if I take a look at this particular combination, could you please tell me how many plates are over here? 1, 2, and 3. And how many plates form one capacitor? Do you guys know how many plates form one capacitor? We say 1 and 1. This forms one capacitor over here. 2 plates forms one capacitor. 2 plates form one capacitor. We say this plate and this plate will form second capacitor. Okay. I'll write the same thing over here. I say in this particular case, we say due to 3 capacitors, due to 3 plates, 2 capacitors are formed. And if 2 capacitors are formed, we are supposed to find the capacitance of this combination. And to find the capacitance in the following combination, To find the capacitance in the following combination. I see. I say this plate is connected to point X. It is having the potential X. These two plates is having the potential Y. So here, we say both of these capacitors, are connected between X and Y, Both of these capacitors are connected between X and Y. Let me draw over here. This is X and this is Y. Okay, see, this first capacitor, it is connected between X. It's one plate is connected to X, another plate is connected to Y. So first capacitor is connected between X and Y. This second capacitor, it is also connected between X and Y. So I'll say these are the two plates in parallel. So C equivalent in this case will be 2C. C plus C, that is 2. So we say equivalent capacitance in this combination is 2C. Let's suppose you have a question something like this. See guys, here you have got one plate, okay, two plates, so it forms one capacitor, second capacitor, third capacitor. Now, potential of this is X and this is Y. And these two plates are connected. So I am saying, let's suppose the potential of this is X, okay? Okay. So I am saying if potential of a point is not given, not mentioned, so I say, let's call this as X. Now, how do we find equivalent capacitance? First of all, how many points are over here? We say mark the points, draw the points. See? We say we have got, or let's not call it X, let's call it A. We have got X, Y, and A. So I can say this is A over here, it's a straight wire, this is also A over here. First capacitor is connected between X and A. Second is connected between X and Y. Third is connected between Y and A. So we have got 3 points, X, A, and Y. First capacitor is connected between X and A. So I'll make it between X. Second is connected between X and Y. So over here, that will be X and Y. Third is connected between Y and A. So I'll make it over here, Y and A. This is C. This is C, C, C. Now these two are in series. When you have the two capacitors in series, guys, we can make it something like this. C and C is in series. How to find the capacitance in series? So C1, C2, C into C upon C plus C. C square by 2. This and this will cancel, C by 2. So they have the equivalent of C by 2 with C. This is C by 2 and this is C. Now these two are connected in parallel. So C equivalent will be simply that is C by 2 plus C. 2C plus C, that is 3C divided by 2. Now find the equivalent capacitor. Equivalent capacitance from the following combination of plates. From the following combination of plates. See guys, in this particular case, this is A, this and this is connected. Let's suppose this is X and this is also X. How many points are over here? This is the first capacitor, this is second capacitor, this is third capacitor. How many points are over here? A, X and B. A, X and B. See, first capacitor is connected between A and X. So I'll connect it between A and X. Second capacitor is connected between A and X. So So I'll connect it between A and X. Third is connected between X and B. So third is connected between X. This is C, this is C, this is C. Now these two are in C parallel. So they have the equivalent of C plus C is 2C. And this is in series with C. Now here we say C equivalent will be C1, C2 because they are in series. So C1 is 2C, C2 is C upon, we say 2C plus C. So now I can say this is 2C square upon, we say 3C. This and this will cancel, 2 by 3C. This is the C equivalent. This is the C equivalent. How many topics left? We are done with the chapter capacitors. Now these are some of the problem types that I'm showing. These are some of the problem types I'm showing. We are done with the capacitor. Now guys, these are the important problem types from the capacitor chapter. That's what I'm showing. Now, if you have something like this, find the net capacitance of the system. Find the net capacitance of the system. Guys, see, you have got this one plate. Potential of this point is A, so this will be also A. Potential of this point is B, so this plate will be B. Potential of this point will be also B, and potential of this plate will be. Now here this entire combination is connected between, we say, A and B. Now this capacitor, first one, is connected between A and B. Sir, this capacitor is connected between B and B. So this will short circuit. Now last one is connected between B and A. I can make it something like this over here. I can make it something like this is C, this is C. And C equivalent in this particular case will be C plus C is, we say, 2. Is this clear, guys? Let's talk about this one. Find C equivalent. Find C equivalent. Guys, you have got this capacitor, this capacitor, this capacitor. Okay, don't you think that these three are connected in series? Okay, these three are connected in series. Now. So I can say, what is the equivalent of these three? That is C by 3. Because if you have got n capacitors connected in series, so we say it will be, guys, C. 1 upon C equivalent, 1 by C1, that is 1 by C, plus 1 by C, plus 1 by C. Okay, 1 by C1 plus 1 by C2 plus 1 by C3. Now this will be 3 divided by C, 1 upon C equivalent. So C equivalent will come out to be C by 3. That's what I was saying. Equivalent of these three is C by 3. Now, if this is point A, this will be also point A. And this is point B. If this is point A, this is also point. Now, guys, here you have got A point, you have got B point. Now, we said this capacitor C by 3 is connected between A and B. C by 3. This last one is also connected between A and B. This is C. These two are connected in parallel. So we say this is C by 3 plus we say C. So I can say that is 3, that is 4C divided by 3. 4C by 3. What about this one? Find the net capacitance. Guys, let's suppose this point over here is A and this point over here is B. Mark the points on your own. If this is B, can I say this is straight wire is going till over here, this is also B. Straight wire is going till over here, this is also B. Straight wire is going till over here, this is also B. Now in this entire combination, we have got only 2 points. Which one? A and B. So this is connected between A and B. Let's make it over here. This is connected between A and B. This is connected between A and B, A and B. Okay. All of these are connected between A, B, C, C, C. So C equivalent in this case will come out. Guys, give me the signal in the chats, then I will move on to the Wheatstone bridge. Give me the signal in the chats, then I will move on to the Wheatstone bridge. Everyone means everyone. And this is the question which is your homework. Find C equivalent. Now this is easy. This is easy. Sir, is this sufficient for AIR1? Yes, this is sufficient. But you guys are supposed to practice more questions from your end. Now, guys, understand this thing. That is Wheatstone bridge. What this Wheatstone bridge is all about. Guys, let's suppose I have got a capacitor over here. I have got a capacitor over here. I have got one more capacitor over here. I have got one more capacitor. Okay. And I have got one more capacitor. Guys, I am saying that if this is C1, this is C2, this is C3, this is C4, and this is C. See, what does the Wheatstone bridge concept actually say? Wheatstone bridge concept says that according to this is Wheatstone bridge looks something like this. If you have the capacitors connected in series, something like this, it looks like Wheatstone bridge. Now, how do we exactly find out if it is a Wheatstone bridge? We say according to Wheatstone bridge. Guys, see, it says that if C1 divided by C2 comes out to be equal to C3 divided by C4, then remove the middle capacitor C5, because potential difference across it is same. The potential difference across it is same. The potential difference across it is. So it says that if by any chance this capacitance by this capacitance comes out to be this capacitance by this capacitance, then you can remove the middle one, because potential difference across this comes out to be same. So we say charge will not be stored over here. So we can remove this one. And if we remove this one, then I say it becomes something like. Then it becomes something like. Okay. Now, if I say, let's suppose this is 2 microfarad, this is 4 microfarad. Okay. And this is 4 microfarad and this is 8 microfarad. This is 2, this is 4, this is 4, and this is 8. Can I not say in this particular case, C1 by C2 is equal to C3 by C4? Yes, C1 by C2 is 2 by 4 is equal to, this is 4 by 8. So 4 1s are, 4 2s are, 2 1s are, 2 2s are. So 1 by 2 is equal to 1 by 2. Then we can remove the middle resistor in this particular, middle capacitor in this particular, and find the equivalent capacitor. Find the equivalent capacitor. Let's suppose if I give you a question something like this, see guys, C1 is equal to C, C2 is equal to C, this is C, this is C, this is C. You guys are supposed to find out in this one, find the C equivalent across XY. You are supposed to find the equivalent capacitance across XY. Now, in this particular case, sir, it will become difficult if it is not a Wheatstone bridge. Now, see, we can clearly say here, C1 by C2 is equal to C3 by C4. Here, C1 by C2 is equal to C3 by C4. So, because this is C by C is equal to C by C, so we can remove. So, remove, I can say C. So, remove, I can say C. If you remove the middle capacitor C5, don't you think that, my dear friends, this and this will come then in series? See, I'll make it. This C and this. And from over here, this one, and this one. Guys, see, this is C, this is C, this is C, this is C. If you remove the middle one, now these two are in series. Now, what is the equivalent of this one and this one? If they are in series, that is C by 2. So I'll make it over here. Equivalent of this one and this one is C by 2. Now, equivalent of this one and this one is also what? That is C by 2. C by 2 and C by 2 are parallel, so equivalent will be C. Equivalent will be C. Okay. Let's talk about this one. Guys, see. What is the, let's suppose if C1 is C, C5 is C, C2 is C, C4 is C, C3 is C. Here also I am asking find the C equivalent across X and Y. I am asking find the C equivalent across X and Y. Is this a Wheatstone bridge? First we have to find out. As of now, we don't know. First we have to find out. Guys, see, mark the potential of every point. Let's suppose this is X over here. Okay. This point is Y over here. You cannot say this point will be also Y because capacitor is in between. Let's suppose this point is P and this point is over here Q. Now, guys, how many points are in this entire combination over here? We say it has got 4 points. That is, we say X, P, we say Q, and we say Y. Now, guys, when we talk about the first capacitor, it is connected between X and P. So it is connected between X and P. And how much is this? This is C. Let's talk about this, which capacitor? C2. It is connected between X and P and Q. It is connected between P and Q. So I'll make it something like this. This is C. Then this one. It is connected between P and Y. It is connected between P and Y. This is C. Then this one, it is connected between Q and Y. It is connected between Q and Y. And then this one, middle one, it is connected between P and Q. This is C, this is C. Now, don't you think this looks like a Wheatstone bridge? Yes. So we can say it is a Wheatstone bridge. How do you get to know that? C1 by C2 is equal to C3 by C4. So I can say C equivalent in this case will be also C. Guys, tell me in the chats, is everything crystalline clear till over here? Is everything crystalline clear till over here? Let me know in the chats. Great. Okay, now see guys, let's take a look at, I don't think after I have shown you every single problem pattern. Now your job is to do the practice from your end. Okay, I have shown you enough number of questions. Your job is to do practice from your end. The more you practice, the more we say perfect you will become in these chapters. That's for sure. Okay. Now, guys, we have the symmetric circuit. Symmetric circuits basically look something like this. Symmetric circuits look something like this. Okay. Now, if you have to find the equivalent capacitance in this particular case, there is a trick. There is a trick. We say flip the circuit. Flip the upper part of the circuit on the lower part. Flip the upper part of the circuit on the lower part. Now, if you flip this upper part on the lower part, now this falls onto this one, guys. Guys, understand this point very carefully. If somebody asks you to find the equivalent in this case, what will you do? You'll flip this. You'll flip this. Okay. Now, this falls onto this one. So then they come in parallel. C and C becomes 2C. Now, see, it becomes 2C. This one will fall on this one. So C, it becomes also 2C. It becomes 2C. This one remains as it is. So it is C. This one also remains as it is. It is C. And this falls onto this one. So it also becomes 2C. Now see, it becomes a Wheatstone bridge. Guys, see, C divided by 2C. C divided by 2C. Now it is a Wheatstone bridge. We say now it is a Wheatstone bridge. Wheatstone bridge. Okay? Because here C1 by C2 is equal to C3 by C4. Okay? So remove middle one. Middle one. So how does it actually look then? So it will look something like this. This C and C and this 2C and 2C. This C, C, 2C, 2C. Now do solve this with the series parallel. C and C are in the series. So we say they will have the equivalent of C by 2. Okay. Then this one. 2C and 2C are in the series. They will have the equivalent of 2C into 2C upon 2C plus 2C. C1, C2 upon C1 plus C2 in series. So that is 4C square upon 4C. This and this will cancel. Okay. Okay. And in this particular case, 2 plus 2 is 4. 2 into 2 is 4C square. And this will cancel. So it will come out to be C. Okay. So it will come out to be over here. That is C. Okay. So now, what is the C equivalent in this particular case? That is C by 2 plus C. So that is 2C plus C is 3C divided by 2. So this is the answer of this circuit. This is the answer of this one. Is this clear, guys? Tell me in the chats. Is this clear? Is this clear? Great. Now, similarly, in this is your homework. Find C equivalent across XY. Here also you'll have to do the flipping technique. Okay. This will fall onto this one. This will fall onto this one. Okay. And this will fall onto this one. This will fall onto this one. This will fall onto this one. You can clearly see 2C, 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 2C. This and this will remain same. That is this one and this one. Now, use the series parallel to solve this particular circuit and get the answer. Next one is ladder networks. Next one is ladder networks. Now, guys, see. Let's suppose if you have got a circuit something like this, and it is going till infinity. C, 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 and it is going till infinity. We have to find the C equivalent across AB. To find the C equivalent across AB. Now, guys, in order to basically solve this question, there is a technique that we use. What is that? We say, cut the circuit over here with this line PQ. Okay? And assume all of this is having the capacitance as X. Okay? Let the capacitance of the circuit from the right side of PQ BX. I'm saying that this is infinitely long. Let's assume that this is having the capacitance X. We don't know, but let's assume it is having X. Can I make it then something like this? Guys, see. We have got this capacitance, and now this is X, this is C, and this is C, something like this. This is P, and this is, we say, sir. So this is X, means from here onwards till infinity, this is having X, And this is C, and this is C. Now, could you please tell me what is the capacitance of this? Guys, see. This X, this C and X are in parallel. So they have, I can make it something like this. This is C, this is sir P, and this is sir Q, this is C, and this will be C plus X. Because if the two capacitors are in series, parallel, they have C1 plus C2 as equivalent capacitance. Now these two are in, we say, these two are in, we say, sir, series. So if we find out the capacitance of these two, how do we find it? We say C equivalent in this particular case will be, that is C1, C2, C into C plus X upon C1 plus C2, C plus X. Now, guys, don't you think that in this particular case, this C equivalent is the potential, this is the capacitance across PQ, across AB, and if I say from here onwards till infinity, capacitance is X. So for infinitely long circuit, capacitance is X. Can I not say from here onwards till infinity, capacitance will be also X? Because from here also till infinity, it is infinitely long. From here also till infinity, it is infinitely long. From here also till infinity, it is infinitely long. So whatever is the capacitance still over here, same will be capacitance still over here. So instead of C equivalent, I'll write over here X. Because this is the capacitance of the infinitely long service, of the long circuit. Is this point clear? Why did I mention X over here? If you are saying, sir, from here onwards, it is infinitely long, it is x. I am saying from here onwards also it is infinitely long. This will be also having x. If from here onwards till infinity it is x, from here also till infinity it is also x. So what is this equivalent of this? Equivalent of this is for all. Equivalent of all. Is this clear? What I'm trying to say is that if I say this is 1, 2, 3 and so on till infinity, I say, how long is this? You say, sir, infinitely long. If I say this infinitely long circuit has got a value of 40, okay? Now, if I say, how long is this, sir? This is also infinitely long. If this infinitely long has got the value of 40, this will be also having the value of 40. Why? Because this is also infinitely long, this is also infinitely long. It's one and the same thing. One or two capacitors will not make a difference. Now follow this. So this will be in this particular case, this is 2c. So I'll write 2cx plus x square is equal to, that is c square plus cx. So I'll write over here x square. Then we say plus 2cx. Then we say minus cx minus c square is equal to 0. 2cx minus cx. So x square plus cx minus c square is equal to 0. Now solve this quadratic equation, then get the value of x, that is your answer. Now solve this quadratic equation and get the value of x, that is your answer. Because x is the capacitance of the infinitely long circuit. Guys, give me the signal in the chats if everything is crystal and clear till over here. Give me the signal in the chats if everything is crystal and clear till over here. Now. We are done with the capacitors, but I have some topics left, one or two topics from the electrostatics. I'll have to complete those. Done with capacitors. Now, guys, I would want you guys, I have some topics. Please don't leave. Please don't leave. I have some topics over here. I would want you guys to comment later on once I end the live stream. Okay. Comment later on once I, no, not extra 1 hour, just 20 minutes more, 20 more minutes. Yes. Okay. So I would want you guys to comment later on how was the session, each and every single thing. Please do let me know later on. Let's talk about, okay. I had few questions over here. Okay, now see, this is a type of question which was asked in NEET 2021. Okay, two charged conducting spheres of radii A and B. We are having the two charged spheres. This is having the radii A and this is having the radii B. Okay, and they are connected to each other by means of a wire. We have connected them by means of a wire. The ratio of electric field at the surfaces. We are supposed to find what is the electric field on this surface. What is the electric field on the surface of B? See, guys, when it comes to the electric field, let's suppose charge on this is Q1, charge on this is Q2. These are the four options. When it comes to a sphere, we say electric field on the sphere is, that is simply KQ divided by R square. Here it is A square. This is electric field on the surface of a sphere. Okay? And then we say divided by E2. So we say over here, it will be KQ, this is Q1, over here it will be Q2 divided by, we say B square, because its radius is B. So I can further say E1 divided by E2 is equal to, so this K and K will cancel. So we say Q1 divided by A, Q1 divided by A square into, we say B square divided by Q2. Okay, this one. Now, one more thing also I would want you guys to remember. What is that? Whenever you connect the two spheres by means of a wire, we say their potential becomes equal because conduction takes place. Okay. So we say, remember this, whenever two conductors are connected, their potential becomes equal. Because whenever we connect the two spheres, we say charge is distributed, charge is shared between the two spheres. If charge is shared between the two spheres, guys, if charge is shared between the two spheres, we say this charge will keep on sharing until the potential of this and this becomes equal. So we say potential of V1 is equal to potential V2. Now, how much is the potential on the surface of this sphere? That is K Q1 divided by R. R is A. What is the potential on the surface of this sphere? That is K Q2 divided by B. K and K will cancel. Q1 divided by Q2 will come out to be A divided by B. Now guys, Q1 by Q2 is A by B. And here, from equation first, guys, Q1 by Q2, can I put A divided by B? So E1 divided by E2 will come out to be. Instead of Q1 by Q2, we'll put A divided by B into, then we say B square divided by A square. A and this and this, so it will come out to be B divided by A. So which option? Option. Is this clear? Is this clear? Basically, I wanted to make you understand this point over here. When two spheres are connected by means of a wire, their potential becomes equal. Their potential becomes equal. Okay, their potential becomes equal. Now, could you please tell me the answer of this question on the same pattern? On the same pattern. We have got the two charged spheres over here. Okay, two spherical conductors of radius R1 and this is having the radius R2 are connected by means of a wire. If they are connected by means of a wire, can I say, sir, potential of V1 is equal to potential V2? Can I say in this particular case, let's suppose charge on this is Q1, charge on this is Q2, KQ1 divided by R1. This is the potential on the surface of the sphere is equal to KQ2 divided by R2. So here K and K will cancel. Q1 divided by Q2 will come out to be R1 divided by R2. Now, what we are supposed to find out? The ratio of surface charge densities. Guys. We have to find out sigma 1 divided by sigma 2. We say what is the value of sigma? Sigma is Q divided by area, charge per unit area. We say sigma is equal to charge is Q. Area of sphere is 4 pi r square. Area of sphere is 4 pi r square. Now write this. So charge on sphere is Q1 divided by 4 pi r1 square divided by. Now sigma 2 will be Q2 upon 4 pi r2 square. Now 4 pi will cancel. So Q1 divided by R1 square. This will go in the numerator. It becomes R2 square divided by Q. Now tell me sigma 1 divided by sigma 2. Guys, Q1 sigma 1 by sigma 2 will be Q1 by Q2. Q1 by Q2 is R1 by R2. Capital R. So that will be R1 divided by R2 instead of Q1 by Q2. Then you have got multiplied by R2 square divided by R1 square. R1 and this and this. So it will come out to be R2 divided by R1. So which option is correct? Option. Great. It is simple. Now, guys, let's talk about a concept that is what we call the charge distribution. Did I teach you this topic in the last? Did I teach you this topic? Please tell me. Did I teach you this topic in the electrostatics? Did I teach you this topic in the electrostatics? I guess we did. Okay. Now take a look. Guys, if you remember, okay, take a look. If you remember, I have told you previously in electrostatics, if you have a charge and if you have a sphere over here, I told you if this is a neutral sphere, because of this charge, if this is a positive charge, it will repel the positive charge from this sphere and that will occupy on another side. And it will repel the positive charge and it will attract the negative charge of the sphere. Because positive attracts negative, positive repels negative. This positive charge will attract the negative charge of the sphere. This positive charge will repel the positive charge of the sphere. Okay. And this is what we call the induction in the sphere. Now guys, listen to me very carefully. Same is the case over here. If you have got a sphere, on this sphere, you have got positive charge. Now, don't you think that this positive charge will listen to me very carefully, guys. It will create, see, like over here, this plus Q was creating negative charge over here. It was creating positive charge over here. One and the same thing. Similarly, this sphere will do the induction on the outer sphere. It will create the negative charge from the inner side. Okay. And positive charge from the outer side. And if this is plus Q over here, we say it will create, we say exact minus Q from the inner side. It will create exact minus Q from the inner. Okay. And if it is minus Q from the inner side, guys, see. If it is minus Q from the inner side, we say same plus Q will be from the outer side. Now guys, I can clearly say in this particular case, what is the net charge on the outer sphere? 2Q plus Q is, we say, sir, 3Q. So we say, I'll write over here. We say, due to the inner sphere, induction takes place on the outer sphere. Induction takes place on the outer sphere. Okay. So we are supposed to find charge distribution on conducting spheres. What will be let me make the new figure over here. We are supposed to find what will be the charge after redistribution. This is the inner sphere and this is the outer sphere. Guys, see, how much is the charge on the inner sphere? We say, sir, plus Q. How much is the charge on the outer sphere? We say plus 2q. Now, because of this plus q, it will create minus q charge over here. This is what we call the induction because of this. Okay. And we say if minus q is from the inner side, we say it will create also plus q from outer side. Now, how much is the net charge on the outer sphere? 2q plus q is, we say, sir, 3q. So, after redistribution, charge on the outer sphere is plus 3q. Now, let me show you one more question. You guys are supposed to tell me what is the charge after redistribution over here. What is the charge after redistribution? What is the charge after redistribution? Guys, see. Find the charge after redistribution. See. If it is plus 2q over here, we say, sir, what about this outer sphere? Will the outer sphere do not do the induction on the inner sphere? We say no. Because the effect of this charge is not in the inside. Guys, if we talk about the hollow sphere or conducting sphere, if charge is present on its surface, we say its effect inside is 0. Q inside is 0. If you remember. So if this is plus 2q, don't you think that if this is plus 2q, it will create minus 2q on this sphere from the inner side. And then we say already it was having plus 3q. Tell me one thing. If it is minus 2q from inner side, how much is the charge from outer side? That is minus 2. So plus through 3q minus 2q will come out to be how much? That is plus q. So after redistribution, charge on the second sphere is plus q. Now if this is plus q, it will create minus q on the outer sphere. And already, how much is the charge on outer sphere? That is plus 5. So if it is minus q, it will create over here minus plus q from the outer sphere. Okay. Now tell me, guys, in this particular case, 5q plus q will come out to be, we say, so plus 2q minus q from the outer side. Oh, I made a mistake. Sorry. Wait. Yes. Plus 2q minus q. If this is minus 2q from the outer side, it is plus 2q. 3 plus 2 is, we say, sir, plus 5q. If it is plus 5q, here it will be minus 5q. Already on this one, it was plus 5q. From the inner side, it is minus 5q. From outer side, it will be plus 5. 5 plus 5 is, we say, plus 10q. Tell me, guys, is this clear? Is this clear, everybody out there? I need the signal in the chats. This charge distribution is an important topic. Tell me in this case. After redistribution, find the charge after redistribution. Find the charge on each sphere after redistribution. See, guys, this is 5q over here. This is minus 5q. This is plus 3q. And this is plus 2q. Now, guys, tell me one thing. If this is minus 5q, it will create over here plus 5q. Always it creates the opposite charge. And if it is plus 5q, here it will be minus 5q from the outer side. Okay. Okay. Now minus 5 plus 3 is how much? We say, sir, minus 2q. Now, if this is minus 2q, it creates plus 2q from the inner side. From the outer side, it creates minus 2q. So that will be minus 2 plus 2 is 0. So after redistribution, on the outer sphere, it is 0. On the middle sphere, it is plus 2q. And inner sphere, it is already minus. So 0, minus 2, and this is 5 already. What if I give you the question something like this? This is the level 2. This is the level 2 question of this one. This is the level 2. Now, guys, take a look over here. If you ever, guys, see, if you ever get a question something like this, you have got 3 spheres. This one, we say inner sphere, then second sphere, and then we have got the third sphere. We say charge on this sphere is given as Q. Charge on sphere B is not given, but it is grounded over here. It is grounded over here. Radius of inner sphere is R. Radius of second sphere is 2R. And then third sphere, charge on third sphere is 2Q. And we say radius of third sphere is 3R. Here, in this particular question, charge on second sphere is not given. We say here, charge on second sphere is not given. So means if you have to redistribute the charge over here, for that you should know what is the charge on the second sphere. So let's first find the charge on second sphere. Guys, see, if it is grounded over here, grounded means potential is 0. Grounded means it is connected to earth. So means earth is having 0 potential, this will have 0. So potential of B will be 0. So let's find the charge. Let's find the charge on sphere B. Let's find the charge on sphere B. Let's find the charge on sphere B. Now, in this particular case, my dear friends, you can clearly see. What is that? That is, as B is grounded. If B is grounded, so what is the potential of sphere B? That will be 0. Now, guys, if potential of sphere B is 0, let's find the potential at sphere B individually. So I say potential at B will be, guys, see, we know this is the inner sphere. This sphere will create the potential at B. This is the outer sphere. This will also create the potential at B. And let's assume the charge on this middle sphere is Q. See, guys. So potential at B will be potential due to inner sphere. I told you in the last class. So because of this sphere having charge Q, what is the potential on B? B is the outer side, we say outer point. So that will be K Q divided by small r. At what distance you are finding? That is 2r. This will be also 2r. This will be also 2. So you have, if you have a sphere, at outside point, potential will be KQ divided by r, small r. And small r in this case is 2r. You are finding at 2r. Now, potential because of the second sphere on its surface will be plus. That is K. Charge we are assuming over here Q. We have to find this Q only. We don't know its value. KQ divided by. At the surface of this sphere is, we say, sir, 2R. Then potential because of the outer sphere at inside point. We know in case of hollow sphere conducting, whatever is the potential on its surface, same will be inside. What is the potential on bigger surface? That is plus. That is 2 times of KQ, because charge on this is small q. Okay. divided by, what is the radius of bigger one? That is 3r. We know whatever is this potential on surface, same potential will be inside. And we say this is 0 is equal to, because ultimately net potential is 0. 0 is equal to. Here, what can you take common? You can take common K divided by R. In this one, it will be Q divided by 2 plus. Here it will be Q divided by this 2. Here it will be plus 2Q divided by 3. Now, if it goes over here, it becomes 0. Take these two over here. Okay, we say it is minus Q divided by 2. If you take it over there, then we say this also minus 2 divided by 3Q is equal to Q divided by 2. Now, guys, take minus common over here. And what will you do? And take minus Q common over here. What will you do in this case? 1 by 2 minus 2 divided by 3 is equal to Q by 2. Now, 3 ones are 3, 2 twos are 4. So, this is minus Q, and this is 3 minus 2 is 1 divided by 3 twos are 6. Okay, is equal to Q by 2. Okay. 2 ones are, I think I made a mistake somewhere. Just a second. In this particular case, what I'm supposed to do is, we say this is Q divided by 2 plus Q divided by 2 plus 2Q divided by 3 is equal to 0. Now take it over there. So we say Q divided by 2 will come out to be. So that is, if you take these two over here, so it will be minus Q by 2. Then we say minus 2Q divided by 3, because in this one it is 2Q divided by 3. Yes. So you can take this as common. This is negative over here. Okay. Or you can do the cross multiply. 3Q. This will be over here. That is 3Q. Then we say plus 2 into 2 is 4Q divided by 2 threes are 6. And it is over here Q by 2. Now this is Q divided by 2 is equal to, in this particular case, we can say over here 4 plus 3 is 7Q. So it will be minus 7Q divided by 6. 2 ones are, 2 threes are. So Q will come out to be minus 7Q divided by 3. Yes. So charge on this sphere came out to be minus 7Q by 3. Now let me rewrite this. Let me redraw the charge on each sphere. This is the best question, guys. This is the best question that I'm saying over here. Now tell me, charge on this is Q. Charge on second sphere is minus 7Q by 3. On this it is Q minus 7Q divided by 3. And charge on the last sphere is 2Q. On this sphere is 2Q. Now, can you do the redistribution, sir? Very easily. If this is plus Q over here, it will create minus Q. From the outer side, it will create plus Q. Okay. Now tell me, this is minus 7Q by 3 plus Q. How much this will be? 3Q minus 7Q. Minus 7 plus 3. That is 4Q divided by 3. So this will come out to be 4Q divided by 3. If it is 4Q by 3, we say on this sphere from this side, it is minus 4Q by 3. And it is 2Q from the outer side. And from the outer side, it will be plus 4Q divided by 3. Now solve this. 3 into 2 is 6. 6Q plus 4Q. 10Q divided by 3. Guys, please tell me in the chats if everything is crystal. Guys, Please tell me in the chats if everything is crystalline clear. Everyone means everyone. Hey, I didn't make any mistake. If still I have made any mistake, please do the calculations from your end. Okay? Yeah, no more energy. So it is, yes, this is minus 7q plus q. This will be minus 4q divided by 3. Yes. So this is minus 4q divided by 3. So it will be plus 4q by 3, and here it will be minus 4q by minus 4q. Okay. Now 3 into 2 is 6. 6q minus 4q, that is 2q divided by. Now it is correct. Now it is correct. Yes, yes, yes. Yo, yo, yo. Next, the last one, just one question. Conservation of mechanical energy. What does this say? It says that total energy initially is equal to total energy finally. What does that mean? That means energy remains conserved. Remains conserved. Okay. So it says that total energy initially is equal to total energy finally. That means energy remains conserved. Okay. Now guys, I can also write this something like this. That is energy initially is equal to energy finally. Even I can write it something like this, sir. Kinetic energy initially plus potential energy initially will be, this is total, kinetic plus potential initially will be equal to, we say, kinetic energy finally plus potential energy finally. Direct, remember this. This is the conservation of energy. Let me show you the question on this one, which will give you the more feel. Guys, see, let's suppose if we have got a solid sphere over here, and it has got the charge q and radius capital R. Okay. And at 2r distance, we have got one more charge over here, minus q, with mass m. Now, we know that this positively charged sphere is attracting this negatively charged sphere. If, my dear friends, I'll release this negative charge over here, if I release it, what happens? It will go towards the sphere. So we say, with what speed it will hit the sphere? With what speed it will hit the sphere? If minus q is released, with what speed it will collide with the surface? I say, use conservation of energy. Use conservation of energy. Guys, what does conservation of energy say? That is potential energy initially plus kinetic energy initially is equal to potential energy finally plus kinetic energy finally, means total energy initially is equal to total energy finally. That is the concept you guys are supposed to use. Now tell me one thing, guys, in this particular case. What is the potential energy initially? Initially, charge is over here. This is initially. Finally, charge is hitting the surface. Tell me, when charge is initially over here, how much is the potential energy? Between this charge and this sphere, potential energy will be simply, sir, that is minus, that is simply over here, minus K. What is the potential energy between the two charges? K Q1, Q2 by R. So here, why am I writing minus? Because one charge is negative. Minus K, Q1 is, we say, capital Q. Q2 is minus Q, that is over here. So this is minus Q divided by distance between the two. 2R plus R will be 3. Then we say plus kinetic energy initially. Initially, it is released. So when it is released, so initial velocity is 0. If we release an object, means initial velocity we consider 0. So we say it will be 1 by 2 mu square. U is 0, so that will be 0. Kinetic energy initially is equal to. Finally, when the charge reaches over here, what is the potential energy between this and this? That will be, sir, minus K Q1, that is Q, Q2, that is small q, divided by R. Now the distance between the two is R. We measure from the center, that is capital. And then we say plus. What is the kinetic energy finally at this point? 1 by 2 mv square. We are supposed to find this v only. Here velocity 1 by 2 mv square. Now take this over there. So it will be K capital Q small q divided by R. Then we say this minus K capital Q small q divided by 3R. It will be equal to 1 by 2 mv square. Now guys, here you can take the common K capital Q small q divided by R. And what you can take in this particular case, 1 minus 1 by 3 is equal to, we say, 1 by 2 mv square. Now 3 minus 2 divided by 3, 2 by 3. Okay, so that is 2 divided by 3. It will come out to be KQQ divided by R is equal to, we say, mv square divided by 2. Now 2 into 2 will become 4. So further I can write over here, that is 4 by 3 A capital Q small q divided by mr. So over here, I am basically multiplying this m with r, 2 with this 2, that is 4. Now here it becomes v square. So it is v square. So velocity will come out to be under root of 4 by 3 aq this q divided by. Guys, is this question clear? Please tell me in the chats. Is this question clear? Please tell me in the chats. सर कपा को जानते हो यार, कपा. Is this clear? Great. Now, guys, we have one more question in this one, but this I'll give you as homework. Okay. Read this properly. There is basically a tunnel over here. This is a solid sphere. If we release this, with what velocity it will cross the center? Okay. Okay. And charge of this is capital Q and the radius of this is, we say, capital R. You guys are supposed to tell me the velocity. And that's all, ladies and gentlemen. Thank you so much. Thank you. Okay, that's all for today. So if you have not liked the session as of now, I would want you guys to hit the like button as soon as possible. And one more thing, I just want to tell you what is that. If when I end the live stream, afterwards, you guys are supposed to basically put up the comments in the comment section. How was the session? Okay. Do let me know how was the session and all. Okay, so take care and bye-bye. Good night. Take a chill pill. Thank you, thank you, thank you, thank you, thank you. Okay. So take care, guys. I need to leave now. Do let me know in the comments how was the session. So thank you so much. Take care. Bye-bye.